Welcome everybody, and let's start with the title. Human-Centric Ride-Sharing on Large Scale by Explaining AI-Generated Assignments. This paper is a joint work of Jörg P. Müller and me, Sören Schleimer, and I will start with some definitions of terms. As ride-sharing, we define the sharing of a personal vehicle with other travelers so that at least two individuals share a common ride in the same vehicle. It has the potential to reduce individual passenger transport and thus greenhouse gas emissions. But one problem is that ride-sharing is not yet popular enough to be seen as an important contribution to the reduction of individual transport. Therefore, we want to make ride-sharing, more specifically the ride-sharing assignment, more human-centric. And as such, we define that after rides are offered and the requests are made, both have to be assigned to each other to satisfy the demand and supply of rides. And their assigning can consider drivers, passengers, and you can also include vehicles if you want. As human-centric, we want to increase the user satisfaction in their assignment process, which we refer to as the human-centric aspect. And artificial intelligence can be used to generate the assignments, and it's also used in the real world. For example, in New York City, on an average day, 1 million trips took place in 2018. And plenty of operators already serve more than 10,000 trips per day with their taxi fleet. So we consider such scenarios, like more than 10,000 trips per day, as large-scale scenarios where an AI-based system can work and also be beneficial. However, one downside of making use of AI is the increased complexity and intransparency of such an approach, and we want to compensate such by explaining the assignment decisions to users and passengers, which again contributes to this human-centric aspect. Before I switch to the next slide, I want to give you a brief overview of the content of this talk. And first I will explain the motivation for doing this research and derive 3 research questions. Then I want to introduce a 5-step research methodology to tackle the raised questions. And after that, I show the most recent results from 2 steps of the research methodology, and I will give a summary after that. In the end, we will also have some time for questions. But now let's start with motivation and research. As mentioned before, ride-sharing can contribute to a reduction of emissions. But the problem is that ride-sharing still lacks popularity. And hence, Leving et al. Argue to increase the user satisfaction in the assignment process. And therefore, we also want to include determinants besides the common price and route in the assignment process. And as a ride-sharing determinant, we define factors that determine the degree of satisfaction of ride-sharing users. And such can be different things, like the classical ones, price and route, and plenty of others, like space on the seat and smell in the vehicle. And you will see some other in a minute. So this refers to the human-centric aspect. As argued before, assignment algorithms are only relevant when applied in real-world and thus large-scale scenarios. And therefore, we want to apply deep reinforcement learning for the assignment process in ride-sharing. This idea is not new. It was already introduced by these 2 papers, 1 and 20, but they do not include additional determinants. But overall, like this deep reinforcement learning approach is with respect to the large-scale aspect of our paper. To compensate the complexity and intransparency introduced by deep reinforcement learning, we also want to develop an agent which is able to explain the assignment to ride-sharing users and therefore contribute again to the human-centric aspect. So far, we came up with 3 research questions to be investigated. The first one is, does including additional determinants in a ride-sharing assignment process satisfy users more? The second one is, does explaining these ride-sharing assignments to users increase their satisfaction level? And the third and last research question is, how much efficiency is lost when making ride-sharing more human-centric by including determinants in the assignment process? And next, I will show you a 5-step research methodology to tackle the raised research questions. The first step of the research methodology was already performed and published in a previous paper, It is to investigate the most important ride-sharing determinants for users. And therefore we performed the literature study, which resulted in 73 determinants. We focused on the 41 which are relevant for passengers, then conducted a survey with 419 participants, and based on the results we constructed an order of importance, which can be used as an orientation for choosing the most important determinants. And because of the relatively small size of the dataset, and because in existing datasets like the New York City taxi data, no determinants are included, we aim in the second step to generate a realistic large-scale ride-sharing dataset that includes the determinants. And this will enable us to evaluate step 3 to 5. Step 3 is to combine deep reinforcement learning with the determinants from step 1 and 2 by making use of a user satisfaction function. This step is called Human-Centric assignments in ride-sharing with deep reinforcement learning. And then in step 4, we will explain ride-sharing decisions created by the assignment algorithm of step 3 to passengers with explainable artificial intelligence. And lastly, we will try to push the explainability further and develop an interactive XAI-based agent that is able to explain these ride-sharing decisions. And for using XAI, we will compare existing approaches of XAI with focus on the user's perspective, and then the generated explanations will most likely be text-based and real-world, and later be evaluated based on the user satisfaction. And in the following, I briefly show you recent results for step 2 and 3. In our previous work in step 1, we asked 419 participants on a 5-point Likert scale for the importance of 41 determinants. And you can see in the graphic the 10 most important determinants, this graphic here on the bottom right. And for instance, when you look at the price, you can see that 40% of the participants answered that the price is important for them. Another 30% said it's rather important, and that's how you can read the graphic. And then in step 2, the idea is to combine the determinants with an existing taxi trip dataset, which we assume can be interpreted as a realistic demand for ride-sharing trips. And because we don't want to use the data from the questionnaire over and over again, we use the existing determinant dataset from the questionnaire as input for a generative model. And this leaves us with several challenges. Because the data was collected on a Likert scale, the data is categorical, and this is a little bit contradicting to continuous data, which is mostly used for generative models. Then it's a relatively small data set, so we have only 419 entries. And for generative models, the evaluation of results is not that clear, so we combined some existing metrics. So far, we applied 3 different generative models. First, the boundary seeking GAN, generative adversarial network, is GAN, and it performed pretty bad. Then we also tried the Gumbel softmax for variational autoencoders. It performed better, but it was also not very good. And we also applied discrete Wasserstein GAN, which we think performed relatively good. And in the graphic on the right, you can see that, for instance, for price, the upper bar plots are from before, but these ones are the second one, always is the generated one, and you can see there is a difference, but it's relatively small, and here it wraps up. So for price, it's fine. For something like low delay at start, it's relatively bad, like this is not learning the generated, but overall, the discrete Wasserstein GAN seems to outperform the other 2, and there's still some work to do. But to wrap it up, we now know the most important determinants. We showed you ongoing work and first results to generate values from the dataset, and we can combine these now with trips from an existing taxi trip dataset. So now let's move on to step 3. As argued before, previous research either applied deep reinforcement learning to the assignment problem or developed a user satisfaction function that consider non-common determinants. And as a user satisfaction function, we consider a function that captures how satisfied one passenger is when he travels with one or multiple other passengers. And for this calculation, we will use the determinants. And we want to include a user satisfaction function in a deep reinforcement learning based assignment algorithm for ride sharing. And to learn about the user satisfaction function we want to build in the future, I will use the following illustration. And this illustration is based on a sample I found on OpenAI Gym and this paper. The environment is a 5x5 grid, which has some walls on the outside and some on the inside. We have 4 possible pickup and drop-off locations, A, B, C, and D for passenger 1. And we have a taxi, the yellow rectangle, that aims to pick up a passenger at the blue location, which is in this case B, and drop him or her off at the red location, which is in this case A. And the taxi has the possibility to move 1 step in each direction and perform a pickup or drop-off. And then I've enhanced this scenario to a ride-sharing scenario. And now we have 2 additional passengers, which can be picked up at this location Y or Z. And the taxi is rewarded with different values, PY for picking someone up here, and PZ for picking someone up here, which represent the outcome of user satisfaction function. And the higher the similarity of 2 passengers, the greater the reward in reinforcement learning is in this case. And the taxi has a maximum capacity of 2 passengers, so it has to decide. And when it's trying to pick up both, it's getting punished, so it should decide going here or going there. So now let's assume the pink scenario, where the reward for picking up Y is 2 and the reward for picking up Z is 10, so this one is good, we want to do that. Overall, passenger 1 is, after some training, is transported in around 70% of the cases, and then we see that passenger Y is not picked up because the reward is lower, and passenger Z is picked up because the reward for that is higher, which is what we've expected. When you look at all these combinations, you will see that transporting passenger 1 is always working. Whenever PY is greater or equal to PZ, the curve ends up here on the top, because Y is a little bit easier to access than Z. And in all other cases, these 3, PZ is going to be picked up. And next, I will summarize this talk. The contribution of this work in progress paper are 3 research questions regarding the inclusion of additional determinants, the impact of explaining ride-sharing assignments on the level of satisfaction of users, and the efficiency loss when making ride-sharing more human-centric. Moreover, we presented a 5-step research methodology to tackle the research questions in the future, and we showed our recent results on generating determinants based on previously collected data with generative models. Furthermore, we showed how reinforcement learning can be applied to ride-sharing with determinants in a simple scenario. The next steps. For step 2, we will enhance our work on generative models with respect to the evaluation, and thereby also fine-tune the models. For step 3, we will apply deep reinforcement learning, and similar to 1 and 20, we are to the papers 1 and 20, which I mentioned, we are currently building a model for estimating the time of arrival in ride-sharing, which is one central component. And we also built a model for the demand prediction, which is another central component. And then we will create a user satisfaction function that can be integrated in the deep reinforcement learning-based approach. And after that, we will start to explain the assignments to ride-sharing users and evaluate their satisfaction and the efficiency of our approach. This list includes all used references and also referring to the acknowledgement. I want to thank all members of the EC Rider project team, and in particular Amos Azaria, Noam Hazon, and Sarit Kraus for contributing the initial idea of increasing user satisfaction in ride-sharing, and jointly with us in paper here, reference S10, promoting the use of XAI in this domain. So I want to thank you for your attention, and now I'm looking forward to your questions.
Hello everyone, I'm Riccardo Martoglia. The title of the paper is An Intelligent Dashboard for Assisted Tweet Composition in the Cultural Heritage Area. First of all, the motivation of the paper. We know that in today globalized and ever-expanding market, companies invest countless resources to reach visibility and to have a strong impact on the online communities. However, it is not at all easy to write successful tweets. And in particular, social media managers know that this is a very difficult task. So it is necessary to know how to compose a tweet to generate a high number of likes and retweets, and so to generate interest in the public. In particular, it is crucial to determine which content feature to use, for instance, images, multimedia content, and the same is for hashtags, mention, links, and so on. In this paper, we talk about this, and in particular, we concentrate on the cultural heritage domain. In particular, in the cultural heritage domain, we consider museums. Museums use Twitter to communicate with visitors. In particular, they use it to promote the museums. They use it to engage visitors. They use it to promote special events. But is this communication really effective? Which is the long-term goal of our research? In particular, it is to design and develop an innovative tool that will provide the museum media manager with effective content suggestions, in particular for writing successful tweets, and to support effective communication and marketing campaigns in the cultural heritage domain. These are some examples of the suggestions that the tool will be able, the final tool will be able to provide. What is the paper contribution? In particular, we present in this paper the ongoing work we are performing, we are doing on an innovative dashboard. The dashboard is able to exploit intelligent data analytics and machine learning techniques in order to provide interesting suggestions and assist the social media manager in composing the tweets. The dashboard is a prototype because this is an ongoing work. The dashboard provides a mobile UI client to help media manager in composing and posting impacting tweets, and it also consists in a server, an intelligent server, which provides automatic tweet categorization in order to predict automatically the impact of a tweet the museum is writing, and it also provides assisted tweet composition by means of suggestion, intelligent suggestion that are provided to the social media manager. So this is the outline of the presentation. Let's proceed with the next step, which is a brief discussion of the state of the art. There are several studies that focus on the analysis of social media data, in particular to promote social-based solutions also in the cultural heritage sector. In particular, Twitter is one of the most known and discussed and studied instruments for sending messages. In particular, there are, we know, almost 500 million tweets every day, and in particular more than 300 million monthly number of active users. So we know that Twitter is very important, and the research on Twitter is also very important. In particular, the mainstreams of research are two. The first one is about sentiment analysis and opinion mining, and it is mainly about gathering of feedback. The second stream is about social network analysis and, for instance, in understanding social influencer, studying social graphs, and so on. We know that there is a lack of approaches, in particular for exploiting social media data and for proactively helping in composing more popular messages, and this is our focus. Talking about dashboard, the concept of a dashboard, of course, is not new. A dashboard, we know, is a user interface providing views relevant to a particular objective, and this is a very common concept in the business sector. There are also several examples in the social media and Twitter area. For instance, we know the tweet activity dashboard, or the International Organization for Migration Twitter dashboard, and so on. There are several examples of dashboard that help in tracking the number of messages and engagements, engagement rate, and so on. However, all these dashboards are not focused on the cultural heritage sector. In particular, they do not exploit intelligent data analytics so to provide useful suggestion in the tweet composition. So let's have a short overview about our dashboard architecture and feature. Then we will discuss the server side and the client side more in depth. The dashboard is composed of a server application and a client application. The dashboard is developed for mobile devices in order to be easily accessible to a large public of users, and in particular, the server application is demanded to store all the past tweet data and to manage all the intelligent tasks, for instance, the suggestion, calculation, and the classification of the tweets. The server handles the classifier model, receives the message from the client, and formulates the suggestion in order to improve such messages. The server is based on the technology that you see on the right side, in particular on Pandas, Scikit-learn, Flask, Pandas, and so on. The client application is a simple and intuitive client user interface that works on Android devices and is developed on Android Studios and using the Volley library. So let's discuss the usage flow of our dashboard. In particular, we will follow this flow by means of a diagram which is shown in the upper part of our slide. So First of all, the user performs login and the server side loads the correct dataset. We will discuss this when talking about server. After login, the user can enter his own message draft and in particular wait for the classifier evaluation, which will be performed server side. Then the user receives a classification for the draft message. The classification, we will discuss this when talking about server, is a binary classification, so the user will receive either a good or bad classification for his message. In case of a good message, the user will have just to post his message. We will see. In case of bad outcome, the user can access and follow the suggestion given by the system in order to improve the impact of the message and so to provide a new version of the message, which will again be classified and analyzed by the server. Once the user is satisfied with the outcome, he or she can log on to Twitter and post the message also directly by means of the application of the UI application of the dashboard. So let's discuss about the server-side component of the dashboard, which is the most complex. First of all, about the data which is stored on the server, we perform data preprocessing. In particular, we considered and stored the tweets, about 20,000 tweets coming from 26 well-known museums. You can see them on the right side of the slide. And in particular, we subdivided this museum into 6 groups according to the number of followers of their Twitter account. In this way, user message will be handled by taking into consideration only the tweets of the museums of the more representative group. That is, the group having similar number of followers. As to the considered features we store in the server, we have the following feature, in particular nLike, which is the amount of likes received by the message. Then we have the number of URL links containing the messages, the amount of images in the tweet, the number of hashtags contained. We see that there are a lot of quantitative features. The number of mentions contained, the length of the message in characters. And we have also a sentiment Boolean value, which indicates the overall sentiment of the message, positive or negative. As we see, these are content features because we are mainly interested in features that can be extracted from the message itself. Okay, let's talk about tweet classification. In particular, we want to perform a binary classification into good tweets and bad tweets. In particular, good tweets will be tweets having the number of likes close to the maximum number of likes received by the tweets of the same group. The opposite is for the bad classification. And so we label the tweets with either good or bad label, and then we perform a k-nearest neighbor classification by means of the Scikit library with a standard Euclidean distance on the normalized features. In particular, we perform a large number of tests so to access the feature, the impact of each feature, and in particular to access the overall classification accuracy. You see in the table the obtained accuracy for the whole feature set, the first line, and for a reduced feature set. In particular, the accuracy for the most significant feature, which we saw being the number of images, the number of hashtags, and the number of mentions, is very, very close to the accuracy which is obtained by considering all the features. For this reason, in the following and in our dashboard, we will consider only these three most significant features. Let's discuss suggestion generation. The idea is to identify positive examples which are near to the given tweet and formulate a feature-based suggestion to improve such message. So, what are the steps? In case of a bad message classification, what is performed? You see in the graph, the original tweet is the green circle. A KNN search is performed, and in particular we are considering for this example key 5, and nearby examples are identified. Then the step is to filter the negative neighbors which are not useful in order to provide useful suggestion to the user. In this case, we consider these two good positive examples. There is also a step which excludes distant neighbors, because two distant neighbors are not useful anyway to generate suggestions. Then we compute the improvement feature as an average of the neighbors featured. In this case, you see that the neighbor have a number of images of 2, 3 hash, and 0 mention. By comparing the average of the neighbors features, the improvement feature with the new message feature, we are able to generate suggestion. In particular, in this case, in this example, the suggestions are there are too many images, or there are too few hashtags, and so on. Finally, let's see some example of the client side and the prototype UI. We have a simple prototype, very preliminary. In particular, this is the login museum selection screen. This is the screen where the user can edit and the tweet draft. These are an example of classification results and some suggestions. Then this is the screen where the user modified the tweet, and in this case the tweet is classified as a good one. And last, the user can perform directly login on Twitter and post the message. So let's conclude the presentation. We have presented an ongoing work in the design of an intelligent dashboard which is able to assist museum social media manager in composing successful tweets. The dashboard is, of course, a prototype, and there are many future work. In particular, in the future, we plan to support effective communication and marketing campaigns for the cultural heritage domain, and we want to consider additional ways of generating suggestions, for instance, by introducing semantics. We also want to expand the set of possible suggestions by considering additional features, such as the time of day when to post the tweet, the specific words composing the tweets, and so on. Thank you for your attention.
Hello, this is Carlo Fantozzi speaking on behalf of all the authors of the Work in Progress paper at home with us. The context of the paper is smart home devices, smart home solutions. We all know smart home devices such as smart plugs, smart lights, smart sensors, and so on, because they are nowadays a commodity sold at cheap prices in retail shops and online. This is a technology that gained ground in recent years. It is evolving in the sense that we still have a ongoing battle among different vendors with different standards, so we have an interoperability issue. But also we have more serious issues I think, of usefulness. Because sometimes there are devices such as, smart microwaves that are not, I think they are not very useful, because you still have to be there to put the food inside the microwave, otherwise you can't operate it. And also we have outstanding issues of coordination among multiple devices, because sometimes you can use the devices as intended by the vendor, but you can't do anything outside the framework provided by the vendor. Nonetheless, these devices offer great potential, and one opportunity is that of reusing and remixing smart home devices for purposes different from the ones intended by the vendors. The purpose we focus on in the present paper is assistance of elderly and disabled people in their homes. This activity also goes under the name of Ambient Assisted Living, AAL. On a side note, I have to say that this is not only a research problem for us, but we are all the three authors are members of an Italian non-profit organization called IT Without Borders, that has the objective of using IT to provide help to people who live in a situation of difficulty. So this is not only a research problem for us, but also, a moral one. The state of the art for ambient assisted living is as follows. One possibility is to design custom device, that is, devices built for a specific purpose. Here is an example. We have a device designed to detect falls of elderly people. You buy it, you put it on the wall, the device floods your house with radar waves, and it detects the fall. It works very well for the intended purpose. It is completely useful for useless for any other purpose, and it costs a lot of money. This is an opportunity, business opportunity for the company that sells it, but maybe it's a problem because not everyone can afford the price. Another possibility is to provide assistance with off-the-shelf components, and this is another example from a site called Limited Mobility Solutions, where a lot of blueprints are published of systems built for specific people. The pictures show that to replicate the setup, you must be proficient with the soldering iron, with the wires, and so on. So the con here is that a lot of ability is required, and also a smaller set of scenarios can be covered, of course, because you can't build custom custom algorithms or custom hardware to help you in your problem. The pro is that a solution based on off-the-shelf components is cheaper and also more easy to replicate. We want to go for the second solution, that is use off-the-shelf components, but without being too goal-oriented, too focused on specific people and specific problems, as is often the case in the literature. So our contribution is not a specific setup, but a methodology. The attempt of providing a more reasoned approach to the problem of ambient assisted living. Okay. This is a work in progress. So far we have devised the methodology to build assistance solutions, that is a set of principles to build assistance solutions. We have identified technologies that are compatible, actual technologies for implementations that are compatible with our methodology. We have identified actual support action in well-known scenarios that can be addressed without the methodologies. And we have finally performed some experiments in one scenario. So the rest of the presentation will go through these 4 points. First of all, the methodology. Our general aim, I repeat it, is to provide assistance to people who exhibit some form of mental or physical disability. The scope is limited to people with moderate disabilities. We call them fragile people. This limitation is caused by the limits imposed by the underlying technology. For instance, if we can detect if a person falls, but we can't raise it him or her up, okay, because this is a limit. For that we would need a custom solution. This is the frontier of research. So nonetheless, there are a lot of situations for people who are basically self-sufficient, who need some form of monitoring, where our solutions are cheaper and easier to implement. The benefits of ambient assisted living in our methodology are twofold. The first benefit is that the fragile person is kept in her or his home as long as possible, instead of moving her or him to an assisted living facility, removing from her home or his home. And the second benefit is that the burden on the caregivers is reduced, because they are contacted only when the situation actually requires their attention. Otherwise, the system is able to perform some sort of monitoring and alerting locally without any notification being sent. Our methodology provides five principles for design. I will now go through the principles. The first principle is, of course, use off-the-shelf hardware components. The motivation is already apparent from what I have said so far. I want to stress here that the use of the dot components or components made by wiring together pieces from different vendors with soldering iron, as we can see in the picture, not only is more difficult, but it also hampers the reliability of the solution, because it is something untested. That's different from an off-the-shelf consumer product that you can buy at the mall or something like that. The second principle is to favor open source components. Here I am talking about both hardware and software components. Maybe we are all familiar with open source software, but open source hardware is starting to appear and becoming popular. For instance, the Raspberry Pi board is an open source piece of hardware, in the sense that if you go to the Raspberry Pi site, you can download the schematics, the blueprints, and you can basically rebuild the board yourself if you have the components. This is the stress on open source is not only a question of cost, okay, because open source is free. It's also a question of ease of modification and mainly of availability, because if you have all the information you need to replicate the system, you can replicate it as long as you want, and no one can remove the product from the market. For instance, the Raspberry Pi board, model Raspberry Pi 3, will remain available at least until January 2026. Of course, among open source projects, there are many tried and tested projects with large communities must be selected. The third principle is to favor open ecosystems and protocols, for instance, for wireless communication or communication of data in general, for the same reasons I just explained. The fourth principle is to favor reliability and availability over technical merit. This may sound obvious, but maybe it is less obvious than it seems in tech-oriented communities. What I'm saying is that if I have to choose between a solution that is technically excellent but may be unreliable, like putting a custom sensor on a microwave to detect the use of the microwave, or detect the user using a smart plug, which is more trivial, I must opt for the second solution because it is more reliable. Concerning reliability, I just want to quickly point out that sometimes redundancy is a cheap option. Okay, sometimes the devices are so inexpensive that you can be redundant. And concerning availability, I want to stress that cloud services may be a problem. If I need a cloud and therefore an internet connection to operate a smart plug, that may be an issue if the internet connection fails and basically my system becomes useless. This is also connected with principle 5 that tells to make the solution as self-sufficient as possible, because every external resource, the internet connection, a remote server, even the power grid, may become unavailable, and the system must continue to function even under such circumstances. Which support actions can be reasonably implemented within our methodology? We identified 3 tiers. The first tier is local monitoring of the fragile person and local actions. For instance, I can monitor the movements of the person inside the house and turn on the lights as the person moves from one room to another. The second tier is sending messages to the caregiver. For instance, I monitor the fridge door. This is tier 1. When I detect that the fridge door was left open, I have to send a message to the caregiver because there is no off-the-shelf solution to close the fridge door. Someone has to do it, or phone the person and tell please close the fridge door. Okay, so sometimes messages are required when the system cannot operate automatically. The third tier is data collection for later analysis. Sometimes the analysis is instantaneous. I mean, if I have a movement detector, I can see instantaneously if someone is in the room. Sometimes the analysis requires several days. For instance, if I detect that the number of toilet flushes increases over several days, there may be an ongoing medical issue that must be reported. Having defined our methodologies, we try to point out specific technologies that can be used within our methodology. As far as software is concerned, we found that OpenHub is a good solution. OpenHub is a gnome automation software. It is open source. It supports devices from several vendors. It supports several operating systems and embedded boards such as the Raspberry Pi. And it is open source. The con is that it is sometimes difficult to configure. Some hacking skills are required, as the documentation says. As far as sensors and actuators are concerned, I have to point out that no vendor can provide all devices for a given scenario, because every vendor specializes in some area. What I can say is that there is a set of sensors and actuators that will appear practically in any scenario with high probability. The list is here in the slide. We have sensors for presence, motion, temperature, light, door window sensors, leak detectors, actuators for lights, power plugs, buttons and switches. And we found that the devices sold by Polish manufacturer Fibaro cover basically all the needs in the list. Here we have some picture of Fibaro products. Another advantage of Fibaro is that the devices use the Z-Wave protocol for communication, which is a very low power, and it is not an open source protocol, but it is supported by several vendors, and the devices from several vendors are interoperable. And so I'm just saying that I'm not saying this is the only solution. I'm just saying that we found that this lineup is good to consider. We are performing further experiments with software, for instance, to check which is the best solution for data storage, and if a solution can be found, to program the intelligence of the system with a visual language instead of the textual language provided by OpenHub. Some support actions in our methodology. I mean, these are not support actions we invented, they are well-known scenarios. We are just saying that in these scenarios we can do something with our with smart home devices. The scenarios are: the night rise, a person must wakes up at night and must leave the bed. It may fall because the room is dark. You can turn on the lights. Front door, someone rings the bell. The person can walk to the door. I can see the identity of the person with a smart doorbell and open the door from remote. The scenario communication, it may be difficult for the person to place a call because doesn't or she doesn't remember the number, or she or he can't operate the phone, and the phone can be operated with the smart button or vocal commands, which are readily available in smart home solutions. Finally, some words about the experiments we completed in the night rise scenario. We performed the experiments inside an assisted living facility in Padova, in an apartment for self-sufficient elderly people. We used Fibaro hardware and OpenHub for the programming the intelligence of the system. And the experiments, I have to say, were performed with collaborators, not actual fragile people, because we need the cooperation of the person to understand whether the system was working or not. We found that the most tricky part to detect the night rise was the placement of the motion sensor. In the end, we placed it under the bed in the position you can see in the slide in the picture on the right. This placement ensured no false negatives, zero false negatives, and reduced the number of false positives, that is, detection of spurious movements like the movements of blankets or something, to virtually zero. So this is a successful experiment. But this is just one experiment. Of course, this is a work in progress, so we have to perform more experiments, consider more scenarios, and identify more concrete support actions, more actual support actions we can implement within our system. At the end of the process, maybe we should reevaluate our methodologies to see whether some important principle was left out. This is a short-term goal. In the medium term, we want to expand our range of devices to include body sensors like smartwatches, smartphones that can be used as both input and output devices. They can send alerts and record data even when the person is outside of the house. And in the very end, it is completely unexplored, the field of data analysis for activity and anomaly detection.
Hi, I'm Giovanni Del Nevo, a PhD student at the University of Bologna, and I'm here to present the context and the research questions of my PhD thesis. The title of my presentation is A Study on the Limits and Potential of Machine Prediction from a Human Big Data Machine Interaction Perspective. In 2009, Schmidt and Lipson were able to distill natural laws directly from experimental data without any prior knowledge about physics, kinematics, or geometry. The experimental data consisted simply in the position of an air track oscillator and a double pendulum over time. Employing symbolic regression and varying the parameters considered, the authors were able to discover Hamiltonians, Lagrangians, and other laws of geometric and momentum conservation. Similar results have contributed to fuel the current of thought according to which big data coupled with machine learning algorithms are engendering a paradigm shift from a knowledge-driven science to a data-driven one. Knowledge-driven science is the one of the scientific method, based on hypothesis testing. Scientists hypothesize models and then conduct experiments that confirm or refute such models. In many fields, such as physics or biology, these experiments can no longer take place, for several reasons. Hence, many are putting into question the scientific method in favor of massive amounts of data and applied mathematics, since they offer a whole new way of understanding the world. As opposed to these positions, many scientists are claiming the importance of conceptual insights even when working with big data and artificial intelligence. Some researchers, for example, affirm that automated machine learning can work only in narrow context. In others, like the medical one, human experts are still required, since they are the only able to understand the overall context. According to their vision, AI technology has to empower or augment humans rather than substitute them, following the human-in-the-loop or the human-in-control paradigm. This conflictual situation does not regard only science, but it is reflected on different areas of the society. In fact, big data and machine learning are profoundly shaping social, economic, and political spheres, becoming part of the collective imagination. Within this context, it becomes of fundamental importance to understand the limits, and consequently the potentiality of prediction made by a machine that learns directly from data. Understanding the limits of machine prediction would allow dispelling false beliefs about the potentiality of machine learning algorithms, avoiding at the same time possible misuses. To tackle this problem, completely different research lines are emerging. Some researchers are trying to determine the limits of such prediction, studying the mathematical foundation of machine learning. A completely different research line is the one proposed by other researchers that have framed the emerging interdisciplinary field of machine behavior, whose purpose is to study the behavior exhibited by intelligent machines in order to be able to control their action, reap their benefits, and minimize their harms. Finally, in contrast to these two research lines, there is an unbridled use of machine learning without any a priori technical reflection. There is not a theory to prove, but there are data. Starting from these massive amounts of data, there is a tendency to use increasingly sophisticated algorithms and then to tune the hyperparameters of such algorithms till the point that some relations are extracted from the data. But very often, such relationships exist only in the dataset and not in the real world. This tendency appends the scientific world. In fact, while before a theory was generally true under certain conditions, now it is possible to define a different theory for each dataset. In this broad spectrum between theorists and those who use machine learning indiscriminately, in this thesis I would like to investigate how the limits of machine prediction influence the interaction between human computers and big data. Such study should produce some high-level reflections that can contribute to the framing on how the interaction between human and computers has changed since the presence of big data and algorithms that can make computers intelligent, albeit with some limitations. Some research questions have already been identified. With regard to the first one, many are putting into question this aura of AI objectivity and infallibility. On our side, instead, identify a key issue around the problem of AI error and bias into an insufficient human ability to determine the limits and the context where these algorithms will have to operate. In fact, while it is of great amplitude the range of what the rational side of the human mind can master, machine intelligence has limited capacity to learn in completely unknown scenarios. Simply, an accurate or incomplete codification of the context may result into AI failures. The second topic to be explored concerns the performance of machines that must be perfect. The claim of perfection is probably a cultural projection of the Western culture and the result of the Christian apocalyptic thinking. This current of thought leads to a binary vision which contrasts technological apocalypse against techno-utopianism. The result of such a vision is a neurosis. On the one hand, there is the desire of a perfect machine able to have 100% of accuracy. On the other, a single case of failure is enough to put into question the whole system. But when working in the real world, the perfect machine does not yet exist. And my intuition is that the key question is not whether or not to rely on an imperfect machine. Rather, it is deciding how much autonomy we are willing to give to them. According to this vision, machines have to evaluate all those cases in which they are highly confident, while humans will analyze the remaining cases, the most doubtful ones, in which the machine tends to make mistakes. In this way, we return to have the same concept of machines that humanity has always had, consisting in taking away the useless work. I thank you for your attention. I'm Giovanni Del Nevo, and here there is my email address for any question. Thank you.
This is the Safe Routes paper presented by Aidan Mackey and Stephen Mistely. Car accidents are the #1 cause of death for people aged 5 through 29, with over 1.35 million people dying worldwide. On top of this, there are over 4.4 million Americans that are injured, resulting in over $380 million in individual medical bills. The United States National Highway Traffic Safety Administration is trying to combat this by giving every car a safety rating from 1 through 5. Furthermore, Google, Apple, Waze, and other mapping services are using speed and other factors to determine routes and road ratings. Despite these efforts, there are still accidents, and a new effort is desperately in need. Safe Routes aims to bridge the gap between the driver and the safety of their roads through the large amounts of road accident data to display the safety rating of every road and any given route. Safe Routes will also allow users to compare different routes and choose their desired ratio of speed to safety. Finally, Safe Routes will bring this data to the light of city governments by highlighting the most unsafe and highly traveled roads to encourage the prioritization of their revision and improve the safety. The Safe Routes product at its core provides road safety ratings, but there's a lot we can do beyond just coloring a map. Our database allows for the ranking of the most dangerous roads in each city, and even ranking cities against each other. We offer intelligent routing that informs the driver of the safety of different routes. And our data allows for a variety of different danger ratings for each road, with the ability to distinctly rate roads during rush hour or only on weekends. The analytical possibilities are endless.
The product is founded in an incident database of more than 6 million accidents strong. We have danger data in 5 continents, with higher concentrations in North America and Europe. So, we want to assign danger ratings to roads. What does that even mean? How can we assign a danger rating to an entire road without losing the nuances of certain areas being more dangerous than others? Let's imagine we want to assign a safety rating to Interstate Freeway 5, I-5, in the United States, which runs from the southern U.S. border with Mexico through 3 states of California, Oregon, and Washington, to the northern U.S. border with Canada This freeway is 1,300 miles long and clearly not uniformly dangerous. Assigning a safety rating for the whole of I-5 would be meaningless, as it wouldn't account for different conditions along the length of the road, or the different terrains the freeway travels through, or even the different speed limits imposed on it across the route. Furthermore, one section of freeway may be packed and experiencing pouring rain, while another is completely dry and free of traffic at the exact same time. Road segmentation is the idea that roads can be split into road segments, essentially chunks of road that can be evaluated independently of one another. These road segments are usually less than 5 miles long and are often defined as being a section of road that does not include exits or entrances to other roads. Hence, on the I-5, for instance, road segments correspond to the stretches of freeway between exits. In urban settings, the road segments are the stretches of streets along city blocks, while in rural areas, each road segment may be many miles long. Evaluating road segments rather than whole roads allows for more specificity and relevancy when relaying data to motorists and authorities. To this end, SafeRoutes utilizes a compiled database of every car accident in the US from the past 3 years in order to rate road segments based off the concentration and severity of accidents that occur on them. SafeRoutes calculates road safety ratings using a variety of factors, such as total accidents, the total volume of traffic, the time of day the road segment is most traveled, and even real-time elements, such as weather conditions, seasonal considerations, and construction. One of the benefits of accounting for these factors, like time of day and day of week and weather conditions, is that it allows us to be able to assign different safety ratings for these various times and conditions. For example, if a particular road is most dangerous at sunset, perhaps due to windshield glare, SafeRoutes is able to determine this due to the increased number of accidents that consistently happen during this time, and thus rank this road as being more dangerous during sunset. Finally, we have 2 separate danger ratings for each road segment that serve a different purpose. First is a score between 0 and 100 that identifies the percentile of danger to which a particular road segment belongs. A score of 90 means that the road is in the top 10% of dangerous roads. This is useful for ranking roads against each other comparatively. For example, this comes in handy for routing, as we need to compare various routes, and thus road segments, against each other, and bringing out their differences is important. The second metric is one of accidents per million vehicle miles traveled. This is a more objective scale, and it offers insight into the danger of segments while accounting for things like segment length and volume of traffic. This is more useful for analytics and other public sector use cases.
Here are some potential use cases for this product. Road safety scores can be used in tandem with traditional routing algorithms to provide information on the safety of each route. Not only this, but users will be given a choice between the safest route and the most efficient route, or a combination of the two. Insurance companies could use our safety ratings to determine the relative risk of particular drivers on a given road. Additionally, our road safety rating system can be combined with user-based insurance to give an insurance policyholder customized rates based on the safety of the routes they choose routinely, or for their regular daily commutes. This can encourage people to use the consumer application, as it will not only help them to find the safest possible route, but also save money on their auto insurance bills. Real estate companies could use the individual road safety scores to help with appraisal of houses and businesses for sale, based on the safety of the streets and roads surrounding the property. The safety score could help label properties as being kid-friendly, pedestrian-friendly, or bike-friendly, and show traffic patterns, or whether it is safe to park cars on the street. All of this information could affect the decision of potential buyers, and thus increase the value of properties on safer streets and roads. Governments stand to benefit from this service the most since they would easily be able to visually see the most dangerous streets and roads in their jurisdictions, resulting in the prioritization of the construction and repair work to make these roads safer. For smart cities, which will be integrating tools and technologies for data management and planning, Safe Routes will serve a huge role as a tool that brings the individual and regional information together, enabling local governments to make decisions that benefit the well-being of their residents. Business-ended transportation could use our dataset to better predict and avoid accidents. Companies which transport goods could use more safety-optimized routes to not only protect the goods being transported, but reduce the number of road fatalities.
We are currently in development of this product in countries like the US, UK, and Germany, in which we have high data density. But it is our goal to take information on these countries and the types of roads in them, to assign danger ratings to roads we don't necessarily have lots of data on in lower income countries. This is because lower income countries are disproportionately affected by road accidents. 90% of accidents occur in lower and middle income countries, despite only containing 60% of the world's cars. We hope our product can help governments address dangerous road segments at both a national and local level, as well as give drivers more information about their routes so that they can make more informed decisions. We are currently developing a consumer-facing mobile application that will allow users to choose between the standard speed-based route and a safer alternative. Ultimately, the app's goal is to allow drivers to begin to make the decision for themselves whether they are willing to sacrifice a bit of time for a safer route. This ultimately comes down to informing drivers about the safest places to drive, and the goal is to reduce traffic fatalities. We asked survey respondents whether they would take a route that was safer, even if it took more time. The majority of respondents agreed, with only 1 out of every 10 respondents saying they would rather take the faster route regardless of safety every time. We believe this is indicative of public interest in driver safety, and that informing civilians can also have an impact on reducing the number of accidents, as well as pushing infrastructure changes at a governmental level that will help to make our roads safer. By using machine learning and taking additional factors into account, such as road geometry, weather, and other environmental, physical, and street-specific aspects of a road, it is our goal to predict risk on every road, regardless of whether historical accident data exists on those roads, or even if the road has yet to be built. This would elevate the Safe Route system to be proactive instead of just reactive to dangerous roads by allowing road architects to calculate the risk of a new road before potentially it even existed.
To summarize, our goal is to reduce traffic fatalities through the distribution of road safety data. We hope that informing drivers of the most dangerous locations to drive will encourage careful driving in these places and push for the renovation of these dangerous roads. We believe that we can truly make the world a better place. Let's get there safer. Thank you.
Hello everyone, it is my pleasure to present to you today the work titled on the use of LoRaWAN technology for independent monitoring of unreliable campus Wi-Fi networks. It's a work done by Sidwan under the supervision of Dr. Marco Zenaro and myself, Dr. Jos Dejila. So as the title said, the work is on monitoring campus networks, and the presentation is subdivided in 4 parts. After the introduction, we'll be discussing why IoT is the best choice for monitoring campus network. And after that, I will present the proposed and implemented architecture before we get to the conclusion. So, as you know, in most campuses, we need internet and also diverse applications which are used through a Wi-Fi and also a wired networks. And in most campuses, there are dozens or even hundreds of Wi-Fi access points distributed on the campus. And they are all linked by wire. And it is important to be able to track the performance of that network. There are a bunch of network monitoring tools commercially available. Some of them are free on the internet. So most of them are linked to the cable network, are linked to the network itself. That means that the monitoring tools also leverages the network's availability to be able to provide monitoring information. So when the network cable breaks, for example, there is a failure at some point, the monitoring cannot be done properly because there is a disconnection. In terms of monitoring networks, most of the time people use tools such as Nagios, Cacti, Zabbix, Xenox, Monitoris, which have their advantages, but also some disadvantages. In terms of advantages, there are well-proven tools with compelling settings and also configuration that you can use, such as a dashboard with graphs, with different colors. And also it allows to not only to monitor the services, but also the resources such as the CPU or the utilization of the memories. And they can also provide alerts, either by SMS or email or other means. However, as I said in the beginning, those tools are most of the time dependent on the network itself that they are intended to supervise. And when there is a failure or availability issues, the monitoring is also affected. The remote monitoring can become problematic when there is a failure at some point of the network. So the idea here in this presentation is to come up with an independent tool for monitoring unreliable campus network, which is the case in most campuses in developing countries. Prior to this work, in terms of related work, we have Aniraj and Or's proposal. They also use the SNMP. By the way, most of the existing commercial tools are based on the simple network management protocol. But this one uses also the simple network management protocol to collect monitoring data from the MIB, so from the management information base located on each of the equipment. But the novelty here is that in this presentation, they can also collect environment data such as temperature and humidity from the room where the device is, and send those information via Firebase for display to the network manager. In addition to this, we also have as a representative work what is proposed by Yunfei and Alexander, which combines SNMP also to collect data from the devices, but uses a SIP, Session Initiation Protocol, to convey that information to the managers, managers terminals, and those terminals can be, the mobile phones or any other handset that they may have, for example. So what we propose here is to use the IoT technology, which give us an independent network that with high range, long range, low power consumption, and this is mostly used for the Internet of Things, to build low power wide area network. And this starts with technologies like Bluetooth to 800 to 15.4 or Wi-Fi or cellular or LPA. LPA, as you can see here, have the longest range compared to all the other technologies here. So in terms of LP1 technologies, we have LoRaWAN here, but we also have Sigfox and a bunch of other technologies. So we prefer LoRaWAN here because of the data rates, but also this is can be a private network and also operator-based network. So private in the sense that we don't need any operator to manage the network for us. We can build it and manage it using the free spectrum, and there is security associated to it as well. We can send unlimited messages per day. So compared to the other technologies, Sigfox, for example, is also operator-based, so you need to subscribe to the service, as for a cellular network, for example. So in terms of affordability, LoRaWAN is preferred. Of course, there is some, quality issues associated to it, but quality that has been addressed in evolved version of the LP1 technologies. So in this architecture, we chose, I would say, the most available and the cheapest one. And we use this architecture over here with a LoRa indoor gateway as the central point to the architecture, while the other LoRaWAN devices are distributed everywhere on the campus. So as you can see here, this is in the a building. We use the LoP4 device for that. Another building, we put another LoP4. In another building, which is a restaurant here, we put another LoP4, and here as well. And for where we put the server, the gateway, actually that's where we also put servers for processing the data, and also for its visualization and display or dispatch, to the different access points. So with this architecture here, we use different tools to be able to process the information. So as you can see here, the information are collected and sent to the gateway forward the data received from each LoP4 to the server chipset. which is in charge of authenticating the devices and gateway, and handle data for integration. And finally, we use the telegraph over here, the TIG, which is a telegraph influx database stack to retrieve, store, and visualize data for decision making. So in the Grafana, we define a criteria to raise an alert to send to our Open Journey, API, and this helps us forward the alerts here to different devices. So it can be emails alerts or SMS alerts and different things. So what we did basically is to able to assess the strength of the signal everywhere on the campus. So we are able to, let's say, measure the Wi-Fi signal, the RSSI, everywhere, and it's a good indication of the availability and the performance of the network. So we can set threshold, for example, and that those thresholds can be monitored. So the LoP4 collects the RSSI from different points of the campus and send them to the gateway via the LoRa protocol. And the gateway transmit the received data to the ChipSAC server, which authenticate the sensors and extract the data that Telegraph retrieve and store in inflow database. And as I said, the Grafana help visualize but also send the alerts through different APIs to different channels, basically, either SMS or email. So in conclusion, what we did here was to provide a low cost, low power, and long range IoT technology for an independent campus network monitoring. And this is something very easy to implement. The devices are very low cost, with less than $50, you can actually get the LoP4 and distribute them throughout the campuses, and with a few $100, you can buy the gateway and use an existing servers to implement the processing and visualization tools on it, and be able to monitor your network independently of your local area network. And this is what we've been able to demonstrate on our campus. And definitively, it is just one of the many applications that can be put on your campus for not only for monitoring, but for other purposes as well. And the same gateway, the same LoP devices, we just need to add other sensors to them to deploy other type of applications as well. So it's like a first, application for an IoT network, independent network on a campus. And this has been very helpful in environments such as Benin, West Africa, which is a developing countries where most of the local area network on the campuses are not that reliable, and efficient. So this offers a performant tool for network monitoring purposes. Thank you.
Hello, my name is Esteban Municio, and I'm going to present this work in progress here in GoodTechs called Cultural Heritage and Internet of Things. This work is framed in the PhD of Elizabeth, and well, she couldn't unfortunately stay here today, so I'm going to present the work on her behalf. So the idea of this work is to apply Internet of Things on cultural heritage. This is not a domain that is normally common in IoT. Normally, when people think on Internet of Things, they think of smart health, smart cities, smart industries. But the cultural heritage domain is also quite interesting because it gives us space to do work on the network, on where to deploy the sensors and which topologies we need to form. Also to work on the data privacy and the security of the network, and also how to implement the different software stacks to build the architecture. So this work is focused in this castle. Basically, this is what Elizabeth is going to do. Is going to study how to preserve, how to conserve the castle while using IoT. So this is the first year of the PhD, so she's now doing a state-of-the-art or analyzing what is available in the literature. And well, we have kind of discovered a lot of works that are already aiming to do this. And it's because IoT is actually quite, as I said, it's quite related with this domain, and it's quite suitable because when you define IoT, you define these smart objects in which, in the case of the cultural heritage, you can basically measure them in terms of environmental conditions, structural changes. For example, if you have a wooden block, you can just assign the smartness of it, and you can track the conditions. You can see if there is any crack or it's going to become damaged in the future. Also, you can apply security to know where exactly this wooden block is in the site, and also other valuable objects. You can protect them, and also you can improve the visitor user experience. So basically, we have found all this bunch of works, and we wanted to pick all the most interesting features of them to apply them in this use case, in the case of our castle. So we have classified the works in mainly two groups. The first is all the works that they aim to use IoT for enhanced cultural spaces. And this includes first, improve the user experience, as I said, and secure protected areas. On the other side is the conservation goal, in which you use the IoT to preserve the site and also perform this predictive maintenance. That means that you can detect possible future damage, for example, in an object before it occurs and it's too late. So the first group, we have classified many works that basically, for example, they use the IoT to, for example, for people that are in a museum or any cultural space. It can be an archaeological site. It can be a museum, as I said. You can, for example, define a specific guided tour, selecting the points that are more interesting for that specific user, and also optimizing the time he has, for example. Also, education activities. For example, you can use IoT to deploy sensors and beacons to track the students and interact with them, to build games or some kind of activities that they require interaction. So, for example, the students can go from one point to another in the museum, collecting information, and so that you can ensure they visit the important parts, for example. Also, like a augmented interaction between the objects and the museum and the users through augmented reality or holograms. So, for example, in a museum, you could go to a place where you see a statue, and then you can, with your smartphone, you can get a 3D image, for example, and you can rotate it. You can select the parts of the statue you want, and then you can get more information of each part. So there are a lot of things available there as well. And finally, also just personalized media delivery. That means that you can, for example, give information to the target user according to their preferences, their age, according many parameters, so that you can, for example, if you can just assign a bit of information to him, and then depending on his interests, you can give more data on demand and so on. Parallel to these use cases, you have also the security-based use cases in which you can just add security to the place. You can add cameras, sensors, ultra high sound sensors, or basically the typical security systems you can find everywhere. You can also place them in cultural heritage sites. And the interesting thing is that you can have your security network, but you can also change them and kind of program it on demand. So, for example, if there is a person that is disabled or handicapped somehow, like they cannot see from the distance, or they are in a wheelchair, you can, for example, move the limits in which people can go, and then you can, for example, just make an exception and make him, you can allow him to go closer to the painting, for example. The second group was mostly about conservation, and we found also a lot of works that they were using a lot of sensors. There are many different sensors that measure different things, from temperature, radiation, chemical substances, corrosion, etc. And then material properties as deformation, deterioration. You can also see that there are cracks in the materials, so you can detect all these things and basically use it for predictive maintenance. That is the next part, in which a lot of works are just working on algorithms to proactively do this maintenance, so that you don't have a damaged object at the end, and you can avoid all the inconvenience. Also, you can, for example, predict things like frost, heat waves, or external factors that could cause further damage in the objects or in the sites in some of the places of the site. And well, regarding IoT, many works identify three main requirements. Low power nodes, because you don't want to change the battery of the nodes every month. You want them maybe to last for years, 5 years, maybe. Some of the works are already up to one decade. Also, you want a reliable wireless network, because you want that all the packets that are sent from the sensors are reliably arriving to the gateway, or basically to the cloud, or where you are storing the data. And the cloud support. This is important because normally you can have a local server, but many works, they kind of count on an almost infinite capacity stored in the cloud, so you can instantiate more resources on demand. So at the beginning, you can just use one instance and increase it as long as you need more processing power or storage capacity. And the architecture is more or less also always the same one. You have your wireless sensor network deployed on field. Then you have your gateways, one or more gateways, and a backhaul network, and the cloud part. Of course, there are a lot of details on them, but all of the works follow this type of architecture. So all these studies are related to the ongoing work, and actually, yeah, we have kind of defined what are the most interesting features of them, and then we are going to take them for the conservation of the castle in Santiago. So, well, these are the general objectives of the PhD of Elizabeth, and we are going to map these objectives that are assess the current state of the castle, restore all the possible damage that it can be found, and finally protect it and conserve it. And we map these to basically detect the specific things or assets to be monitored. These can be from as I said, a wooden block, a wooden platform, a painting in the wall, a fresco. So identify all these things, then design the architecture that is going to interact with these objects, to monitor them and use this data to conserve them, and finally to develop an algorithm to for some cases try to prevent that they get damaged. So you can, for example, do this preventive maintenance. So we have picked some of the most interesting things from these works from the state-of-the-art review, and we are going to apply them to the specific objectives in this castle, applied to this castle. So, for example, things that we have identified has been the wooden platforms in the mezzanine, the main bridge. These are all things that can be monitored because they are subject to a lot of problems, and they are maybe the most vulnerable things. Also, the moat, the cistern platforms where the canyons are. So these are some of the things that have been identified. And in these places, at least, we are planning to perform weather monitoring, just general weather on the site, on material humidity and temperature, so that we can detect the inside and outside humidity and temperature measures and track them on time. Salt corrosion and rust level, this is specifically for the parts that are closer to the sea, and metal things like cannons and metal parts of the bridge, for example. Fissures and cracks for any type of wall or structure, and mold presence that it can also affect to the frescoes in the walls or the paintings that are inside of the site. And we have also identified the big challenges that are most relevant in this use case in Santiago de Cuba, in the castle, and is that, first, there is no internet connectivity. There is only a 2G connectivity that is not really stable because it's quite far from the city. So that makes that it's really necessary to have a kind of backhaul technology that takes the data from the castle and transport it to a place where there is connectivity. Also, there is no computer resources, so the same apply. Most of the computing task has to be done outside of the castle, or at least some part of it. like the most heavy ones. There is also not a lot of IoT qualified personnel available. So ideally, this network should be kind of out of the box deployed. So you get the nodes, you go there, you deploy them, and the network kind of configures itself. Also, it should be self-healing. So if there is a problem in a link, for example, the node should select another link, another parent to send the data to. So yeah, ideally this network should be kind of as less self-assistant as possible. So without requiring a lot of personnel, I mean. And finally, also, if you want to do algorithms to detect and to do early detect and predict some misbehaviors or damage, you have to start from scratch and get the data on site, because there are no previous data sets. So you don't know how really the material behaves with the weather, for example, along the year. So you may need few years to get statistical data, to get statistical significance, so that you can, in the future, you can kind of train your algorithms properly. And yeah, so that's all. Yeah, these are some details of the project. It's a VLIR UOS program funded by Flanders. Well, you can check here more information. And of course, if you want more information, just more technical things, you can write us, and hopefully we will be delivering more updates on the state of this project. So thank you, and see you later.
Greetings to everyone. My name is Prachi Vadatkar. I am a research fellow at International Center of Theoretical Physics, Italy. I am presenting the paper entitled on time synchronization of LoRaWAN based IoT device for enhanced event correlation. This work has been done under the supervision of Dr. Marco Zenaro from ICTP Italy and under the collaboration with Professor Pietro Manzoni from University of Valencia, Spain. So this is the outline that I will be going through as the presentation progresses. I will start with the introduction. As the LPWAN technologies are becoming prominent in the era of IoT, that is Internet of Things, LoRa emerges as a good solution. It provides long range along with low power and limited bandwidth. It has been developed by Symantec and is based on a cheap signals. LoRaWAN is defined as the communication protocol, while the LoRa physical layer enables the long-range communication link. It has a star topology, where gateway converge to so-called network servers that enable low-power device to exchange data with applications. In this context, the Things network that provide a set of open tools and a global open network to build IoT applications at low cost. IoT applications require that all nodes are synchronized with network and with each other. Time synchronization in LoRa network is needed to support message transmission in a timely manner. The overall aim of this paper is to present an overview of three possible setups for the challenging task of time synchronization of nodes in LoRaWAN. Clock synchronization. In wireless communication, time synchronization is a challenging task. For enhanced event correlation, the timely delivery of the message is crucial and effective. However, the real end device can present the time drifts such as shown in this figure. Time synchronization helps to adjust the drift that occurred in the time of end nodes concerning standard time and with each other. Time synchronization in wireless communication networks provide a common time frame along with other functions such as message transmission, channel scheduling, and that should place in a correct order. of an IoT application require that all nodes are synchronous with the network and with each other to exchange time critical information and warning messages to provide an enhanced event correlation. Clock synchronization in LoRa and LoRaWAN. IoT application based on LoRa nodes assume an RTC at each node that the node needs to be synchronized with a common reference time. Since LoRa nodes operate independently, their RTC may not be synchronized with each other. This can lead to difficulties when trying to interrupt information sent at different nodes. In the era of IoT and wireless sensor network, the clock synchronization problem has already been studied. Many synchronization algorithms rely on the clock information acquired using GPS. However, GPS has its own drawbacks, mainly derived because of the power consumption and cost efficiency. LoRaWAN does not incorporate a time synchronization protocol, nor it includes the time related information in the message header, but only slack timing requirements because of long duration. End device receive slot timing. There are three types of classes in the end devices: Class A, Class B and Class C. Class A end device allow bidirectional communication based on Aloha type protocol. These devices are application specific and keep transmitting until there is a message from the gateway. To get this downlink message from gateway, it should wait till uplink transmission. Figure shows that how the Class A end device receives slot timing. With Class B device, all gateways must transmit synchronously beacon of time reference, which is called as ping slots, while the network infrastructure to initiate a downlink communication. The application layer requires the network layer to switch to Class B mode from Class A. The beacon must be transmitted, and if no beacon has been received, the synchronization with the network will be lost. Then the MAC layer must inform the application layer that the device has been switched from Class B to Class A. Finally, Class C devices. Class C device can listen all the time except in transmit mode. They are ideal for applications requiring more downlink transmission but will utilize more power compared to Class A and Class B counterparts. We describe the three methodology for time synchronization among nodes using LoRa network that we will evaluate. For this experiment, we have used PyCom Low-Pi 4 node with PyCom expansion board. Nodes under test were configured with 868 MHz European frequency band and the spreading factor was set to 7 to minimize the time on air and obey the duty cycle regulation. So this is the first methodology, time synchronization using Wi-Fi. In this approach, the NTP, which is Network Time Protocol, is used to synchronize the internal RTC real-time clock of the devices. We perform the experiment using two nodes under test and one master node. One of them, the master node, to compare the time difference between the other two nodes under test. The nodes under test were set up with the same configuration of frequency, power and spreading factor. To activate our measurements, we used an external pin interrupt sent to the general purpose input output pins of the nodes under test. When the external pin interrupt was triggered, the nodes under test obtain the time value by requesting it to the network time protocol. On receiving the value, they write it to the corresponding RTC registry, which is the real-time clock registry. Once the RTC is set on the nodes under test, the master node executes a callback function triggered when the input level of the output pin changes from both nodes and calculates the time difference between them. Finally, the master node sends the time information, time difference between the nodes two nodes under test to the TTN server. To optimize this process, we have set the system to get the external interrupt every hour. Time synchronization using TTN downlink. The second methodology. The second methodology is based on the use of the information embedded in the TTN downlink, that is the the things network downlink message from the gateway. The nodes under test on receiving a synchronization downlink packet write the time value to the corresponding real-time clock registry. In the things network, the downlink messages are allowed but limited to 10 messages per day. Here is the raw downlink packet format, where the device ID has been shown and the port ID has been given to 1. The confirmation it is given whether the end node should give the acknowledgement to the gateway or not. The payload raw is encoded with base 64. The Unix epoch timestamp is encoded into a binary format in the payload raw filled by the gateway. It consists of 16 bytes, which represent time values of millisecond, second, minute, hour, date, month and year. The confirm field was left unchecked, setting it to true, and it is only necessary if the acknowledgement from the node is required. Port was set to 1 in all the cases. Once the downlink message is received at the LoRa end device, they extract the time information from the downlink packet and correspondingly set the real-time clock device and raise the pin interrupt for the LoRa master node. The master node calculates the time difference between the nodes under test. The frequency of the downlink message was set to 1 every 4 hours to comply the TTN limitations. The master node calculates the time difference between the two node. Time synchronization using GPS. The third methodology is based on the GPS timing information. For this experiment, we have used PyTrack board from PyCom that has GPS plus GNSS chipset. This board provides the precise time in addition to longitude, latitude, altitude and speed. The acquired timestamp through GPS consists of milliseconds, seconds, minute, hour, date, month and year, and the GPS information. Write the time value to the appropriate registry in the RTC. After stamping the real-time clock, the node under test raises an interrupt at the master node, where it writes the time value to the appropriate registry in real-time clock at both interrupts. After that, the master node calculates the time difference observed by it between the two nodes under test. We present the result of the experiment we performed to determine the time synchronization methodology. The configuration of the LoRa end nodes is the frequency has been set to 868 MHz and the spreading factor is 7 and the payload is 16 bytes long. During this experiment, no packet loss has been observed. The figure shows that the result opted with the Wi-Fi based methodology. Time difference is indicated in microseconds and total 25 values are plotted. The minimum time difference was observed 347 microseconds while the maximum time difference is 458 microseconds. The mean value is 358 microseconds. Time difference observed using TTN downlink methodology. Time difference is indicated in milliseconds, spans between 2 milliseconds to 55 milliseconds. A total of 13 values are plotted. Extra latency is introduced since the downlink channel transmits only when the receiving window is open. The minimum time difference obtained was 2 milliseconds and the maximum difference was 54 milliseconds. The mean value has been calculated is 12 milliseconds. Time difference calculated using the time synchronization of using GPS methodology. Time difference is indicated in microsecond, lies between 840 microseconds to 2 milliseconds. A total of 25 values are plotted. The mean value is 939 microseconds. For this experiment, we have used the PyTrack board, which have high power consumption and the cost efficiency. Conclusion. paper, we focused on the use of LoRa network for time synchronization among various nodes to support message transmission and critical data sharing in a correct real-time manner. When providing a reliable collaborative service, clock synchronization is necessary. For example, to apply the artificial intelligence solutions in Internet of Things. We have evaluated this different methodology using commodity low-cost hardware so that our solution could be adopted even in low operating expenditures or rural contexts. We have observed that whereas the TTN downlink method can help to synchronize the device remotely with the help of gateways, the time difference between the nodes achieved is in milliseconds, an order of magnitude too high for some applications. Using GPS time synchronization can achieve better results, but it costs extra power for the hardware and as well as the cost efficiency. Finally, when the internet connectivity is available through Wi-Fi, for example, the time synchronization using network time protocol pooling can give accuracy in microseconds, thus making it the best choice. Thank you for your attention.
Hi, my name is Silvia Torsi and I'm here to present a paper called Eudaimonia and Behavior Change, which is about incorporating negative feelings into game design elements. Behavior change is a concept developed in the last decades aimed to facilitate the modification of routines in order to acquire healthy habits. Gamification, on the other hand, means including game design elements into healthcare in order to reach health goals. Until now, several unsuccessful attempts have been made to apply gamification to this field. The reason for that is that gamification disregards a systematic involvement of negative emotions occurring during the modification of the habits, like frustration and dissatisfaction. For this reason, we propose the application of game design principles and methodology in the behavior change field. I will describe some constructs that I will use in this presentation, then I will relate them each with the others. Let's start with eudaimonia, a concept coming from ancient Greek civilization. Eudaimonia is mainly about constructively coping with the negative events and finding enjoyment in getting over them and gradually reaching the final goal. Eudaimonia is about well-being, adaptation, self-acceptance, self-accomplishment, positivity, self-actualization, maturity, and self-improvement. In sum, eudaimonia is about the achievement of a positive, warm, self-confident, yet challenging frame of mind. Into the feeling of eudaimonia, difficulties are contextualized and positively approached, while proceeding towards self-actualization. Following, I will describe a more recent concept related to game design, the one of flow. Flow is about absorption in a challenging activity while being focused in it and getting satisfaction from it, and excitement as well. Flow is a feeling that lies between anxiety when the task is too difficult and boredom when the task is too easy. It is possible to obtain a flow zone by scaling difficulties and then making them reachable and progressive. Eudaimonia and flow are similar because they both are positive emotions that do not exclude difficulties, but incorporate them into a broader, playful context in which self-improvement is pursued by emphasizing control, feedback, fun, incremental goals, and progressive difficulties. Now I will dive more deeply into the constructs of game design, starting from the definition of game. A game is a defined environment located into the real world with spatial and temporal boundaries governed by rules. A successful game creates a magic circle, that is, a closed system situated out of the ordinary life of player, in which the story of the game and its rules allow them to escape daily life, forget about problems and worries, experience beauty, enjoyment, and freedom while having fun. There are several approaches for creating a game. One of the most consolidated is the play-centric approach, allowing the creation of mechanics and narratives. The former are the constraint of the game, evident in its affordances and rules. The latter are the story elements of the game that overlap the mechanics. The main argumentation of this presentation is that experiencing adversity in gaming is unavoidable. We propose to embody that into well-designed games. Thus, negative feelings are incorporated in the game and receive a precise role into the games. In fact, negative feelings in behavior change are unavoidable, but if we include them in the design by using motivational affordances and toolsets of game design, they can be perceivable, manipulable, and shareable. This can be demonstrated by applying the theory of distributed cognition to this approach. In distributed cognition, artifacts and representation are considered cognitive structures external to people's minds and embodied in the real world. This representation provides material tools for human reasoning that is relieved from inner thinking by means of tangible external artifacts for perception, manipulation, and sharing. Therefore, game design elements can determine the externalization of behavior change emotion and facilitate their perception, manipulation, transformation, and sharing. For example, while supporting the retention and the pursuing of both short and long-term goals, keeping track of behavioral alterations over time, facilitating inferential reasoning, associate causes to effects, optimistically weight goals against results, provide context-sensitive information, suggest possible activities, facilitate the sequences of actions to be performed, divide the goals and thus make them less difficult, facilitate decision-making, provide perceivable tools and notifications that facilitate attaining goals. Now I will relate game design with distributed cognition. An affordance is an invariant property of the environment that suggests a conservative action that is possible to be performed with it. An affordance is also what we perceive on an object or a tool that has a corresponding, complementary, predetermined response in our brains. The game design mechanics and rules that are constituted by the material constraints of the games can also be considered affordances. Affordances restrict the field of action and delimit the space of a game. Therefore, it could be possible to start from affordances embodying the negative feelings that occur in behavior change in order to make sense of them and resolve them. They could materialize the progressive challenges the player has to face and in the end provide a feeling of eudaimonia or flow. But what are those negative feelings occurring during behavior change? They have been modeled by a theory called cognitive dissonance that states that people tend to go back to behaviors that are harmful for the health even though they own a set of beliefs that could lead them to positive behaviors. Those two contradictory states of mind of an individual cause discomfort. A variant of cognitive dissonance is self-discrepancy, stating that when people compare their perceived self to their real one, they feel frustrated. In this sense, user experience and player experience are apparently similar, but they have important differences. In both UX and PX, it is important the externalization of inner thoughts and cognition, but while in UX the affordance brings the user to an effortless, thoughtless reaching of the objectives, in PX the affordance set up a challenging environment in which negative feelings emerge in an ordered and planned way, so as for the player to obtain enjoyment, flow, and immersion. Therefore, in this paper, I'll try to provide some coordinates for making research into behavior change by following the theoretical framework I have explained. Thank you for your attention.
Our paper is titled Enhancing Health Access to Remote Infant Screening. I am Khushi Gupta and I am a student at United States International University, Africa. I will be taking you through the introductory slides of the presentation. This presentation entails the following aspects of the project, namely background, proposed solution, system design, implementation, security aspects of the solution, results and discussion, conclusion, and future work. Babies are required to visit a healthcare facility periodically from birth until they reach the age of 5 for growth monitoring. However, access to basic child healthcare services often requires a mother and her baby to make long trips to the nearest health facility. It takes them hours to get to the medical facility where they often have to queue due to the limited health clinics. This chart from UNICEF shows us the number of deaths per 1,000 live births as of 2017. Though the number of deaths have significantly decreased over time, the rates still remain unacceptably high, with Africa having more deaths compared to the rest of the world. There is need for a way to reduce this high rate of infant mortality in Africa. The problem is further compounded by the fact that in many developing countries, the patient-doctor ratio is very low. In Kenya, for example, there are 13.8 doctors, nurses, and physicians for every 10,000 people, less than 3 times the World Health Organization's recommendation of 44.5. Providing affordable remote healthcare monitoring can help reduce infant mortality and provide healthcare workers with actionable information to plan for early intervention. This research sets out to find a technical solution for enhancing healthcare access to infants to reduce the high mortality rates by providing early warnings for timely intervention. The main contributions of this work include designing a user-centered IoT platform for monitoring patient health, integrating analytical and machine learning algorithms for describing the patient's condition, and generating actionable information for timely interventions based on the data collected. Our proposed solution addresses these gaps mentioned above through improved access to healthcare. We plan to address these gaps by creating an IoT device that can be used to monitor growth parameters from the comfort of their home. The IoT device can be used to monitor growth parameters like temperature, height, weight, and skin conditions of the baby and immediately send them to the doctor remotely. The collected measurements are then filtered and compared to get medically relevant insights in the form of health alerts. To generate alerts, the data collected is compared against WHO statistics to evaluate the baby's growth. The alerts and charts generated by the web application can be viewed and analyzed by the doctor for immediate intervention. Our envisioned impact of the proposed solution will be more timely administration, treatment for patients at the comfort of their homes, significant reduction in the cost of intervention, and improved quality of healthcare.
Hello everyone, I am Jeet Gohil. I am a student in the United States International University, Africa. I will take you through the next set of slides. We will now be discussing about the design of our system. The design of our system combines a variety of technologies to provide innovative functionalities for regular infant screening and monitoring. The process begins with the input of initial patient details such as gender, location, and guardian contacts during registration, and the birth measurements when the patient is born, such as height, weight, skin condition, and temperature. Upon registration, the patient is issued with a registration number for identification, which will be required during subsequent measurements. Data collected is transmitted to a database for analytics. The skin condition is analyzed using image recognition algorithms and a pre-populated training dataset to detect skin issues. Reports for monitoring growth and alerts are generated and displayed on a web page accessible to authorized stakeholders. The stakeholders include parents, guardians, medical providers, or government health representatives. A three-tier architecture consisting of a presentation, application, and database layers are used. The client tier provides an interface for the user of an IoT device to capture the input and a website where the stakeholders can register the baby. This layer is also used for data visualization of reports and alerts. This layer consists of a front-end framework called React.js, which is a JavaScript library that is used to build comprehensive user interfaces. The application layer hosts an API to an image recognition algorithm for classification of skin condition images. This layer also includes an optical character recognition model which helps us scan text, for example, the registration number of the infant. The layer consists of Node.js, which is a JavaScript runtime environment, and Express.js, which is a minimal and flexible Node.js web application framework that provides a robust set of features for web and mobile applications. The database layer comprises of a MongoDB database that stores all the measurements taken, which is the actual dataset, the training data, and the results of image recognition. Several sensors were assembled using the Arduino Mega 2560 board for this project, which provided more input-output lines, more sketch memory, and more RAM. The following sensors were integrated in the board: an OV7670 camera module, which captures images of the infant's skin and the infant's registration number, a load cell and HX711 weight sensor module, which measures the weight of the baby, an ultrasonic distance sensor, which measures the height of the baby, a temperature sensor, which measures the temperature of the baby based on the amount of heat energy generated, and a Neo 6M GPS module is used to find out the location from where the measurements were taken. To support the IoT interface, the following devices were also embedded. A backlight LCD display which displays measurements taken such as weight, height, and temperature for input validation. An Ethernet shield allows the Arduino board to connect to the internet using the RJ45 Ethernet pack and to read and write to a SD card using the SD library, and a lithium polymer 7.4 volt battery in order to power the Arduino board. We simulated the process of taking measurements of the baby without using an actual baby. To measure the weight, we used a 2 kg load. Upon weighing it with our IoT device, you can see the measurement is 1.96 kilograms, which is very close to the actual weight. The next step is to take the temperature of the baby. The LCD screen now displays the temperature that has been recorded. Next, we measure the height using the ultrasonic sensor. To show the accuracy, we place an object 8 cm away and place a ruler next to the sensor to confirm. We can see it accurately measures the distance between the sensor and the object placed as 8 cm. To simulate the skin conditions, an image of a baby is placed on a wall and the camera takes the image. All the data is then sent to the database. This is our dashboard where records and global charts are displayed. Our web application has a filtering feature which makes it easier for the doctor to locate records. The doctor can view any record shown from the list and look at how the growth pattern chart looks like. We can see the baby details on the left and the alerts on the right. This record has the status serious because 3 parameters are outside the acceptable range. We can see the baby is underweight, underheight, and has rashes. The doctor can view the growth charts for weight, height, skin conditions, and temperature of the baby. The growth charts contain plotted threshold lines to make it easier for the doctor to understand the extent of the issue. The charts also have a functionality to remove irrelevant threshold lines according to the gender of the baby. In our case, the baby is a boy, thus we remove the threshold lines for a girl.
I am Dharmik Karanya and I am a student at the United States International University, Africa, and I shall be taking you through the next set of slides. For this system, several security aspects were integrated in the design to enhance security and privacy. First, use of authentication tokens for secure transmission of information. The web page uses authentication tokens to securely transmit information between parties as a JSON object and to authenticate users as they sign into the web page. Second, role-based access control. The system also has different access levels for different stakeholders, namely administrator, data analyst, doctor, and registrant. For instance, when an administrator signs in, they can see all the information for all the patients, but if a data analyst logs in, they can only see aggregated information. Third, encryption of passwords. All the passwords used to log into the system are encrypted. Fourth, provision of opt-in and opt-out consent models to give patients control over their data privacy and enhance their trust. These are the results obtained from testing the developed system in relation to the design considerations discussed in the previous section. The innovative aspect of this research comes from the calibration and configuration of simple, low-cost sensors to create a solution that is scalable, accurate, affordable, and portable. We thus describe the results obtained in relation to affordability, accuracy, scalability, and portability. The designed solution can work with several integrated sensors. To test the application, various sensors were embedded and configured in the Arduino board and measurements taken to determine the accuracy of the system. For example, the weight sensor had to be calibrated before measurements could be taken. We use the calibrated mask method for calibration, where the load cell calibrates each time it is used. Readings were taken with no added masses to calibrate the 0 point, after which calibrations were done using known masses. The results depict that the system can read data from several sensors and write it to the database. This section focuses on describing the system's accuracy to address users' concerns. To get accurate results, we tested our IoT devices using predetermined measurements. For example, we placed a 2 kg load on the load cell 50 cm from a wall and maintained it at 25 degrees Celsius at location 1.2184 degrees south and 36.8791 degrees east. The results displayed in the table illustrates that the IoT interface accuracy levels were within acceptable ranges when the average of 10 separate measurements was taken. To model an accurate classifier, the system had to be trained for optimal results. The results in the table shows that the classifier was able to detect the presence of a rash when a colored, black and white or blurred image was used. The other innovative aspect of the research is cost effectiveness. The solution needs to be affordable for people in marginalized communities. Thus, we used low-cost sensors. The total cost of the assembled components was $91 at the time of writing, the equivalent of a low-cost mobile phone as shown in the table. The cost can be further reduced by mass production and communal sharing. Additionally, it eliminates the need for costly hospital trips and reduces the strain on limited health center resources. The device can also be shared within a close community to reduce the cost further. Users in marginalized communities need devices that can be easily moved around to facilitate sharing within the community as necessary. The assembled device weighs 0.65 kilograms and can fit into a 20 by 20 by 10 centimeters box. The solution is placed on a weighing scale and next to a 30 centimeter ruler as shown on the figure to illustrate the results. This is approximately the size of a notebook computer, which validates the portability requirement.
Hello, I am Abdulhamid Ali. I'm a student in United States International University, Africa. I'll take you through the final sets of slides. In conclusion, we have presented the early results of a solution that enables growth monitoring to be conducted remotely from an infant's home. Existing devices used to screen babies require skills, are not portable, and are often too expensive for mothers to acquire. Additionally, they are only found in healthcare facilities, which forces parents to travel to the healthcare centers every time screening needs to be done. A proposed system aims at improving the general health of infants, especially in marginalized communities. More work can be done to enhance the system. Future work includes the addition of sensors to measure the infant's breathing pattern and heart rate to detect additional health issues such as pneumonia early for timely intervention. Pneumonia is one of the key contributors to infant health mortality in developing countries. Additionally, the image recognition module can also be improved by finding ways of making the input process less involving for the caregiver. The next step also involves rigorous testing of the developed system in the field where users will be given the system for a period of time to collect data. The solution can then be properly packaged for commercialization and marketing purposes. I would like to thank you for your attention and time. Please get in touch if you have any questions.
My name is Licia Calvi, and I work at the Breda University of Applied Sciences in the Netherlands. My research is about digital storytelling. I have been involved in several projects where augmented reality is used with storytelling purposes. In all these projects, there is a question that is always coming back, a question that is lingering, and this question is, what is in fact AR storytelling? To be more precise, what do we know about it? While there are many applications of AR in different domains, from education to tourism and leisure and culture, there are not as many studies evaluating the impact of such a technology on users' exploration and navigation, learning, enjoyment, and interpretation. and even less studies are available on the more fundamental question of what AR storytelling is, with the exception of Azuma's work. Ronald Azuma discusses in a paper from 2015 the three possible functions of AR storytelling. According to him, these functions are reinforcing, reskinning, remembering. In this presentation, I would like to delve more into Azuma's notions of remembering and try to understand better what AR storytelling is. To this end, I will use, as a way of example, a project I was involved in. It is the Crosswords project. But first, I need to define what remembering is according to Azuma, and then to briefly introduce what the Crosswords project is about. According to Azuma, remembering occurs in AR storytelling when memories are used to retell stories at the location where they first took place. The assumption is that combining memories presented in the form of stories and real locations in an AR product can produce an experience that is more powerful than any of these two elements considered alone. Of course, we still need to define what powerful really means in this context. With the Brabant Remembers videos developing Crosswords, a similar approach was adopted. But first, I need to explain what Crosswords is. Crosswords is a project about World War II in Brabant, which is a province in the south of the Netherlands. For this project, we created a narrative concept and storylines according to which 75 stories related to World War II heritage sites in Brabant were rewritten, selected from the more than 1,000 stories that were initially collected. Of these, 11 were turned into AR videos for the Brabant Remembers app. These videos tell personal life-changing stories of ordinary people who found themselves at a crossroads in their lives at the end of World War II and had to make life-changing choices. The story that is told in these videos took originally place at the location that is nowadays commemorated by the physical site. This is often a museum commemorating the theme represented in the story, but it can also be a monument, like the tank in this picture commemorating the story of General Noce, who liberated Breda at the end of the war. At that location, the AR app can be opened, and the viewer can experience the event that took place there. This is why these videos are also an implementation of Azuma's remembering. The difference with Azuma's original formulation being that, as the viewers of the Brabant Remembers videos are not the protagonists of the original story themselves, since the real protagonists have in many, if not in most cases, already passed away, the experience of reliving the story at the real location after it happened originally is not just more powerful for them, because it is different. It is simply new for them. I want to look closer at another Crossroads example, namely the story of George and Ursula Levy, which took place at Camp Vught, a deportation camp for children in the south of the Netherlands. A museum is now at the site of the original deportation camp to commemorate this humanity tragedy. The link between the story and the heritage site is that the two children were detained in that camp. The story in the AR video tells that at one point, when they were about to leave that camp to be brought to another one, which was an extermination camp, something happened that made their life and destiny twist. So, this story is told using AR, with the assumption that it will be more effective. But the question remains lingering. Is it really so? Is AR the right tool for this? Answering this question implies defining what AR storytelling is and what it can do in terms of comprehension. This is in fact a more fundamental question that is related to the value of AR as a narrative tool, rather than to the value of AR as a mere technological device. Unfortunately, I don't have an answer to this question yet, but I find it relevant and intriguing enough that I would like to explore it further. I found recently a paper by Gunnar Lichtol on this topic. It compares AR storytelling to hypertext literature. I think that this is a very effective analogy. In the golden age of hypertext literature, as a matter of fact, scholars were asking themselves the same question. What makes hyperliterature so good, and is it good at all as a literary genre? I think that next to the question of the impact on users that I mentioned earlier, and that essentially depends on the use that is done of AR, and that in fact mainly relates to AR as a technology, AR storytelling is, in the first place, a new literary genre. From a narratological perspective, the fundamental elements of storytelling, which are setting, characters, plot, conflict, theme, and a satisfying narrative arc with setup, motoric movement, turning points, climax, and resolution must be maintained even through AR then. But then the question becomes, how and are these elements still effective in this technology? If we take George and Ursula's story again, in the video, the viewer assists as a passive participant at the moment in which the SS officer who is selecting children to be transported to extermination camps asks George whether Flo, the older girl behind the two kids in the screenshot, who had taken care of both children in Camp Vlucht until that moment, is with them, if they still need her. George was at that moment 13 years old, rather young yet to answer such a life-changing question. He does not have much time to ponder his answer, and replies that in fact they don't need her. So Flo is put on the train and sent to an extermination camp. She is convicted to death by George's reply, while both George and his sister remain in Camp Vlucht and eventually survive the war. The video shows this turning moment. The story is built up through setup, motoric movement, turning points and climax, but there is no resolution. The resolution is in fact a question to the viewer on what they would have done if they were in George's shoes. And here stops the video. But we don't know how effective this is as a story in terms of comprehension. We do not know if it has the same power to capture the viewer as a well-written piece of fiction would have. And more questions remain. What are the challenges and opportunities of locative fiction? Can AR storytelling become the new literary genre in the same way as upper literature was in the 1990s? This is something that needs to be explored still. So, despite the proliferation of the AR application, we still don't really know what its efficacy and impact on users for navigation and learning, exploration and enjoyment is, and even less how effective it is, if effective at all. On AR storytelling as a literary tool, and even further as a new literary genre, not much research has been conducted yet, with a few exceptions that I have indicated. I have myself no answers, but only more questions. And also the belief, shared by others, that probably, like with hypertext literature in the 1990s, tools for understanding it will have to come from narrative theory. Thank you.
Hello everybody, this is Silvia Miri from the University of Bologna, and I'm going to present the paper entitled Building an Italian-Chinese Parallel Corpus for Machine Translation from the Web. This is a joint work that we have conducted together with our colleagues from the School of Applied Sciences at the Macau Polytechnic Institute, Professor Rita Tse and Professor Sukit Tang, and my colleague Professor Giovanni Pao and Professoressa Paola Salomoni from the Department of Computer Science and Engineering at the University of Bologna. First of all, I'm going to mainly describe the main motivation and goals that have conducted our work. I'm going to describe the main approach that we have taken into account and we have identified in order to create a data set of sentences that can be used in the automatic translation from Italian to Chinese and from Chinese to Italian languages. And then I'm going to describe the evaluation of the dataset that we have created, and then I'm going to conclude my presentation by presenting some future work. First of all, which is the main motivation that have conducted our work? Okay, we have taken into account that being able to understand the text in different languages can be strategic, can be a key in particular while we are moving or traveling across different countries which are characterized by different languages. So it could be very useful, have information and the ability to automatically translate from one language to another one when we're dealing with different text written in different languages. In order to do that, we need bilingual corpora. So they are critical resources because they are at the basis of every state-of-the-art automatic translation system. So building a parallel corpus is the main activity and the first activity that we have to conduct in order to create an automatic translation system. But it is usually a very complex and very expensive operation, because in order to be able to generalize the relationship between texts, the translation algorithm requires a large set of data. And if already translated texts are not available, then we need some experts, some human experts that have to know both the involved languages, and then it is requires such a kind of experience to translate one language into the other one, and that is very expensive and a very expensive operation, both in terms of costs and in terms of time. So our goal is to automatically building an Italian-Chinese parallel corpus. And then our idea was to use such a corpus with the aim of training an Italian-Chinese neural machine translation to support automatic translation mechanism. So the main aim of our work is to build such a bilingual parallel corpus in an automatic way, creating a sort of pipeline in order to translate and to create a link between a text or a sentence written in one language to the corresponding translation of such a sentence. In order to reach such a goal, our approach was based on the identification of data sources available on the web. Our idea was to try to exploit textual resources, documents already available on the web containing information and textual documents written in both Italian and Chinese languages. For instance, containing news or article in both that language in order to create our corpora. And then we have defined a pipeline as follows. Scraping the text on the web, extracting the text from the HTML page on the web, and then preprocessing them by removing empty paragraph, by substituting particular punctuation marks and symbol and so on, and then aligning the sentences so as to obtain our final parallel corpus. This is a schema that represents our pipeline. First of all, we have our source selection, and then we have the web scraping, so scraping the text on the web, and then the text extraction, so extracting the text from the HTML page, then the text pre-processing by removing empty paragraphs, substituting particular punctuation marks and symbols and so on. And then we have the alignment that is based on documents alignment, paragraphs alignment, and then sentences alignment, which is maybe the most complex operation. And finally, we can obtain our parallel corpus. So first of all, web scraping module of our pipeline. We have searched on the web in order to find out some sources that we can exploit, and then we have used the Google Search API in order to collecting links of articles from some authoritative sources. In particular, we have found out an Italian newspaper that provide articles written in Italian language and the corresponding translation in Chinese language, and we have taken advantages of that. Then we have downloaded the content of a given link. In this way, we have collected almost 2,000 links to Chinese articles written from 2009 to the beginning of this year, 2020. And we have found out that 808 articles had their corresponding translation. And we have exploited such set of articles as our data set to conduct our experiment. And then we have extracted the textual content from the source links. In particular, that is a module that is customized, and in particular because the HTML structure of a source can significantly vary site from sites, but also can vary during time if we take into account the HTML structure of a source, of a specific source, that could vary. And so we have built different components by exploiting a Python library named Beautiful Soap. And this module has been specifically customized because it could change during time. So substituting, and then the third phase, the third module of our pipeline is the text processing module. The idea is of substituting the punctuation marks using the Chinese text with the ones of the Italian language, collapsing sequences of periods into a single one, removing text parts not belonging to the article, for instance, the translation names or other similar metadata that could be added in the article, and then substituting periods between numbers and removing any empty paragraph. Finally, we have the most complex phase, which is based on the alignment module. That has been the alignment has been conducted at 3 different levels: documents, paragraphs, and sentencing. Actually, documents was already aligned because they were already paired in our case study. And then we have the alignment of paragraphs, but we have analyzed the number of paragraphs for each pair of articles, and more than the 60% of the article have the same number of paragraphs, so they were already aligned. And the remaining require a very, very simple action that we were able to conduct in a manual way by the author of this work. And then for the sentence alignment, we based our algorithm on the fact that parallel paragraphs should contain similar punctuation marks, and that if numbers are reported, they should also be present in the corresponding translation. So we took advantages of these facts. Then, regarding such sentence alignment, 2 paragraphs are put on 2 separate lists, and then iteratively, for each element of the list, we looked for numbers that are both in the Italian and the Chinese strings and saved them into 2 different lists. Then, once we find out the best alignment, the text is divided using the periods that follow the number. And then we have looked for round and square brackets, quotation marks, columns, semicolons, and so on. If in the two texts there were the same amounts, the same numbers of one of them, then the texts were split using the next periods, the next punctuation marks in the text. And finally, if the text contains the same amount of exclamation marks, question marks, periods, and so on, they were used in order to divide the text. So these steps were repeated until they do not generate a split in the text in order to find out the sentences. After the execution of such a sentence alignment algorithm, we analyzed how many sentences have been generated automatically by our algorithm and how many paragraphs still consist of 2 or more sentences. A sentence is correctly aligned if it does not contain any period, any question marks, or any exclamation mark, both in the Italian and Chinese version. Finally, after launching our algorithm, it divided the articles that are our data sets, into more than 6,000 aligned sentences. After that, we conduct an evaluation of the accuracy of our sentence alignment algorithm. The alignments were evaluated within the relative paragraphs that are their context, and we assign a 0 value or 1 value. 0 value was assigned if the alignment was completely or only partially incorrect, while 1 value was assigned if the alignment was completely correct. According to the Cochrane formula, we considered a sample of 136 alignments, and we found out that only 15 alignments were partially or completely incorrect. That means that 89% of the whole amount of alignments were correct. So this result was surely mainly depends on the translation of the article that was largely structured in the same way as the original one. So was due to the goodness of our dataset of the resources on the web that we have taken into account. So concluding my presentation, we have proposed a pipeline for building a parallel corpus extracting from the web, taking into account textual document on the web. And in particular, we have focused our attention on Italian and Chinese languages, given to the lack of an Italian-Chinese parallel corpora. The sentence of the textual sources we have taken into account were aligned with a specific algorithm we have defined on the basis of the pipeline we have identified. And some tests, some evaluation that we have conducted show that about 90% of the sentences were correctly aligned. The final corpus consists of more than 6,000 parallel sentences translated both in Italian and Chinese languages. As future work, our idea is mainly based on try to employ automatic paragraph and sentence alignment method. So the idea is that the output should be validated by human experts, taking advantages of the human-machine intelligence collaboration. And finally, once we have obtained a significant parallel corpora, our idea was to training an Italian-Chinese neural machine translation so as to support automatic translation mechanism. I would like to thank all my co-authors, all the audience of the GoodTechs conference, and also Above all, I would like to thank Giovanni Del Nevo, who gave us some very useful suggestions in order to conduct this research. Thank you.
Hello everyone. I really hope you enjoyed this 3-day of conference. I'm Katia Prandi. I'm General Co-Chair of this GoodTechs 2020 edition. On behalf of the organizing committee, I really would like to thank all the participants who attended this 3-day of conference and all the authors who submitted really high quality paper. Moreover, I would like to thank John, my colleague and General Co-Chair, who unfortunately cannot be here. So get well soon. And now I really would like to give, let's say, a human face to the conference. This year was completely virtual, unfortunately. But with this call, we really want to say hello to you and thank you, the participants, with our, say, face. So now I will start asking you, all the people of the organizing committee, to present briefly yourself or Elsa. And so I will start with the program chair, Umbretta.
Hi everyone, I'm Umbretta Gaggi. I'm from University of Padua in Italy. I'm a member of the steering committee and I'm also the program chair of this edition. I would like to thank you, all the authors who submitted paper to this edition, this very particular edition, and also all the review who help us in the review process. Bye-bye.
Thank you very much. And now special session chair.
Yeah. Hello, everybody. My name is Amir Buyari, and I'm an assistant professor at the University of Bologna, Italy. This year, I was acting special session chair, and I wish you have and will enjoy the presentations scheduled for this year's edition. Have a good time.
Thank you very much. Work in progress chair. Who would like to start? Silvia.
Yeah, it's me. I'm Silvia Mirri from the University of Bologna, from the Department of Computer Science and Engineering. And for this GoodTechs edition, I've served as work in progress and PhD track chair, together with Professor Pietro Manzoni.
So, hi everyone. Thanks, Silvia. My name is Pietro Manzoni. I'm a professor at Polytechnic University of Valencia. And with Silvia, I took care about the work in progress and PhD track chairs. I hope you enjoy the session and see you next year.
Thank you.
Hello, everyone. I am Professor Carlos Calafat, also from the Technical University of Valencia. So this year, I had the pleasure to be a publications co-chair together with my colleague Julio Sangüesa. So I've been actively participating in this conference for a few years now. It is a very nice community, and I hope this year you really liked this event as well. So bye-bye.
Thank you.
My name is Julio Sangüesa. I'm from the University of Zaragoza, and it has been a pleasure for me collaborating with my colleagues in the organization of this conference. Thank you so much.
Thank you. Claudio, keynote chair.
Hello everyone, I'm Claudio Palazzi from University of Padua, and I'm part of the steering committee. And for this edition, I also served as keynote chair. So we had 2 keynote speeches during the main event. Professor Nuno Nunes and Professor Liven de Maretz were the speakers. And we will also have another talk later during the workshop, Dr. Luis Carrascal Crespo. So let me thank all of them for their help and very interesting contributions.
Thank you very much. And now last but not least, Joao.
Hello everyone, it's a great pleasure to be here. My name is João Santos. I'm with Trinity College Dublin. For this year's edition, I was web chair, taking care of the website, user experience, and now the blog posts. I really hope you appreciated this year's edition, and see you the next time.
Thank you very much to all for your presentation. And now I really would like to remember you that in the afternoon will be the workshop. It's the first time we will have a workshop at GoodTechs. It will be a workshop related to data protection for healthcare, and it's really enjoyable. So if you want to just attend, please just continue to see this video on YouTube. And thank you again to all the participants, all the organization, Joan and so on. And I really hope to see you next year. Bye.
Bye-bye.
Bye-bye. See you.
Good afternoon, everybody, and welcome to this workshop on data protection for healthcare organized by the Protego project. Health data, medical data in general, is typically very sensitive data, so data protection is an important issue there. So you really want to protect the security and privacy of this data. And this is even getting more and more important as now we are using more and more e-health services, online medical services, and there obviously you want to protect this data as well. And so this is also the main central theme of the workshop. So we have a very interesting program for you this afternoon. So the first presentation we have after my welcome message is a keynote presentation on the Protego project, which is actually working on data protection for healthcare. After this keynote presentation, we have another project presentation, more precisely from the Curex project, which is working on safeguarding health data exchange. Then we have a Q&A session and a break. And then after the break, we are discussing another topic, which is also a very important topic nowadays, is about data sharing and data protection with respect to COVID-19. And so we have two very interesting presentations in this time slot. We first start with the DP3T, which is decentralized privacy-preserving proximity tracing, which is sort of the blueprint for now most of the proximity tracing apps which are used to fight against the COVID-19 crisis. And then we have finally a presentation from Claudia also on open COVID data sharing. Then again we have a Q&A and then we close the workshop. So just for some practicalities to repeat, so the presentations will be on YouTube as you are already watching now. And then so all the Q&A sessions will be on Slack. So there you can ask questions to the presenters, discuss some more things, and you find here the link again. But you should all have received it via email. So without further ado, now let's start with the first presentation of this workshop, the keynote presentation on Protego. Thank you.
Welcome to the presentation about the Protego project. Data Protection Toolkit, Reducing Risks in Hospitals and Care Centers. We are happy to present it in this workshop on data protection for healthcare under the umbrella of the GoodTechs conference. What kind of project is Protego? It is a project funded by the European Commission as a research and innovation action under the Horizon 2020 program. The general objective of Horizon 2020 is to build a society and a world-leading economy based on knowledge and innovation across the whole Union, while contributing to sustainable development. The organizations that make up the Protego consortium are the following. 3 private companies, GFI Spain as coordinators of the project, IBM Research in Israel, and ICE in the UK. 2 hospitals, Marina Salud in Denia, Spain, and Ospedale San Raffaele in Milan, Italy. And 4 universities, IMEC in Belgium, Leuven in Belgium too, Universidad de Alcalá in Spain, and University of Southampton in the UK. But why Protego? Why is there a need for a data protection toolkit to reduce risk in hospitals and care centers? Nowadays, we're not surprised to see news related to cybersecurity issues, not just in general, but more specifically in the healthcare sector. So, news items like the one you can see right now, the one in front of you, give us an idea of the current situation. Healthcare sector is far too vulnerable to cybersecurity threats. And this is not an old news clip, it is last year's. cyber attacks, security breaches. The list goes on, and they are rampant. The purpose of the Protego project is to create a data protection toolkit to reduce risks in hospitals and care centers. Because in hospitals and care centers, there are many actors that either produce or consume very sensitive data. There are physicians, nurses, specialists, management, legal, IT staff, and above all, patients who are the owners of the information. On top of that, there are many medical devices that produce data. And all of us, medical staff or not, want to access our data from our own devices, anywhere, anytime. That increases risk. And there are many that want to take advantage of that, because medical data has a very high price in the black market. What does Protego do about it? It provides an integrated toolkit to assess risk, to monitor risk, and to reduce risk. And all those tools are linked together to be more efficient. How is risk reduced? By protecting data in all its stages. Data at rest, inactive data that is stored physically in any digital form. Data in transit, data that is actively moving from one location to another, such as across the internet or through a private network. Data in use, active data which is stored on a non-persistent digital state, typically in computer RAM or CPU. In all those stages, data is encrypted. And encryption keys are not distributed throughout the infrastructure, but are stored on a central repository that is coupled with an access control framework. Additionally, mobile devices are provided with continuous authentication that guarantees the user is authorized. Nevertheless, no matter how much data is protected, there is always a weak link that can easily be broken, the human factor. That is why Protego also includes an educational framework to train users. What are the objectives of Protego? 1. Holistic approach to protect data from electronic health records against cyber risks generated by remote device access. The result: a complete cybersecurity framework covering the complete life cycle of cyber risks and composed of both IT and educational solutions for all types of end users. How is this objective achieved? Well, we defined functional and non-functional requirements. We detailed real-life situations and introduced a set of evaluation metrics. We also designed a raising awareness program addressing the insights obtained after surveying some 300 healthcare employees. We implemented a new approach for continuous automatic risk assessment, and we developed a holistic end-to-end approach to protect data. Two, improve situational awareness during an attack in two ways: by improving vulnerabilities awareness at organizational level, and by improving awareness of risks and relevant security responses at working level. The result: an integrated risk awareness solution composed of a risk design and analysis tool and event management solution to identify potential system weaknesses and get alerts. How is this objective achieved? Well, we implemented a new approach for continuous automatic risk assessment, including IoT, the Internet of Things, and BYOD, bring your own device, threats. Doing that can improve situational awareness and provide decision support for actions to manage risk at runtime. 3. Protect sensitive data inside the hospital infrastructure and at the boundary between hospitals and BYOD and IoT domains. This is done securing the BYOD and IoT gateways by using a new generation of hardware enclaves. Also, by designing and implementing a modular encryption system for medical data at rest to ensure safe storage and efficient access. Also by developing a software architecture and tools to securely bootstrap and manage the access to medical data by external devices. And finally, by ensuring the isolation of the sensitive traffic data from the devices to the hospital network. The result, a secure and effective framework and tools to support data exchange between BYOD and IoT gateways with the hospital applications, increasing the protection from data hacking at rest and during an exchange. How is this achieved? We developed an end-to-end approach to protect data in all its stages as described before. 4. Cybersecurity solutions for electronic protected health information released as an integrated toolkit. Basically, we put together the results from objectives 2 and 3 to provide a complete IT solution for healthcare networks and their interconnected external devices. The result, a cybersecurity toolkit covering the complete cyber risk lifecycle. And how is this objective achieved? We prepared an integration toolkit for the Protego components that shows how they can be integrated using a beyond state-of-the-art system for research and medical applications. 5. Provision of an educational framework. That framework is made up of methodologies and protocols for the correct usage of cybersecurity tools for attack prevention and reaction to be used by health sector staff, both IT and medical, and patients. The result, an educational framework, tools, and material to understand how to prevent and how to behave against cyber attacks. How is this objective achieved? As stated before, we designed a raising awareness program addressing the insights obtained after surveying some 300 healthcare employees. And 6. Validating scenarios involving emerging technologies in healthcare informatics, IoT and BYOD. 2 different partners provide their real environments in order to validate results. And the expected result for this objective, the reports describing the evaluation of the proposed IT solutions and educational framework. How is this objective achieved? We validated the currently developed functionality in isolation, and we are in the process of validating the first integrated prototype. To achieve those objectives, research has to be carried out in the following areas. 1. Design time risk analysis for the applications operating in their intended environments, like hospitals, patients' homes, and so on. By design time, we mean when the security measures are determined, so they can be applied to existing information systems. The expected impact, better awareness of security risks and security measures at working level. For example, the importance of patches, network segmentation, and so on. 2. Runtime security monitoring and threat responses. The integration of design time models with intelligent CM technology helps users respond correctly to any incidents. The expected impact, better situational awareness at organizational level of vulnerabilities and possible responses before and during attacks. 3. data protection using advanced encryption, and where appropriate, hardware-enabled secure enclaves. The protection of critical processes and encryption of data at rest. The expected impact: reduced vulnerability at gateways that provides a layer of extra protection for data during an attack. This contributes to security in depth, the multi-layered system of security measures to increase protection. 4. Secure bootstrapping and management of secure network communication. Management and distribution of the cryptographic keys to allow authorized parties to decrypt the medical data. Network slicing on the infrastructure to enhance the security from end devices to hospital cloud. The expected impact: data protection of medical information records that adds extra protection against information disclosure of sensitive data. Again, this contributes to security in depth. And 5, understanding the complexity of the application of cybersecurity technologies and techniques. Domain analysis to identify current weaknesses and gaps with cybersecurity solutions application and adoption. When it comes to users' involvement, to find the most appropriate way to create awareness and promote commitment, we have to include psychological research related to incentives. At the same time, Protego needs to analyze and consider hospital staff requirements and knowledge, so adoption of tools and guidelines are ensured. The expected impact: involved parties are trained to prevent cyber attacks and know how to correctly react in case they occur. Let's now focus on the tools in more detail. First of all, risk assessment and risk monitoring. Traditionally, risk assessment is performed with spreadsheet-type tools, where assets are outlined and also the potential threats to those assets. Then, for each cell, the likelihood of each combination of asset and threat to happen is given a value. This is a very tedious process and is not easy to maintain. Protego includes the Secure System Modeler, or SSM, that allows to assess risk more visually. Besides adding assets, relationships between them can be established. Once the model is constructed, many things can be automated. First, for the model to be validated, the SSM produces a list of threats and misbehavior sets. After validating the model that includes potential threats and asset misbehavior, it is possible to calculate risk levels. Those risk levels depend on the trustworthiness attributes for assets, which determine the likelihood of threats. In addition, this is combined with the SIEM that monitors risk at runtime. The SIEM, or Security Information and Event Management, collects data about monitored systems from different data sources. For example, system logs, service logs, application logs, network packets, etc. Besides passively monitoring what goes on, the SIEM also actively monitors vulnerabilities in the different components of information systems by regularly performing vulnerability scans. Based on the vulnerabilities that the SIEM finds, the integration of both tools, the SSM and the SIEM, allows to recalculate risk dynamically in an automated way. This improves situational awareness because it gives a vision of system security not just at a given point in time, but up to date according to the latest vulnerabilities discovered. And this is not just a one-time process. It is a cycle that takes place for as long as an information system is alive. As far as we know, there is no other toolkit that does this, and it is clearly where Protego goes beyond the state of the art. Let's now deal with the tools to reduce risk. Going back to the data protection described before, data at rest, data in transit, and data in use, the risk mitigation tools work together with the following architecture. Like in all information systems, there are data producers, data consumers, and data. In the specific case of healthcare, the standard protocol to interchange data is HL7, and FHIR is the latest evolution. Data is stored in Parquet files that use the Parquet modular encryption, protecting data at rest. Parquet modular encryption has recently been accepted by the Apache Parquet community, and it is another accomplishment where Protego goes beyond the state of the art. The data gateway is the central piece that takes care of that. And it is combined with the access control framework that, among other things, centralizes encryption keys. Using the latest techniques, network slicing provides two types of isolation for both wired and wireless networks, protecting data in transit. Privacy slices for confidentiality, and performance slices for availability. Key components run on enclaves that provide full memory encryption, protecting data in use. Last but not least, mobile devices are protected with the first endpoint detection and response system with continuous authentication capabilities. To assemble all the components, the following cutting-edge open-source platform is used for the software development lifecycle. Starting with GitLab as a continuous integration and continuous development system, software components are packaged using the de facto standard Docker containers. Helm is used to package all the toolkit with possible dependencies. Those technologies contribute a lot to maintain a stable continuous integration and continuous development environment. The whole package is deployed on Kubernetes clusters that orchestrate the containers. Those clusters are managed by Rancher as a single pane of glass, whether the Kubernetes clusters are on-premises or in the cloud. Finally, services are provided by Istio as a service mesh. Istio is a dedicated infrastructure layer for facilitating service-to-service communications between microservices. Besides the evident benefits of using this architecture, there are benefits from the security point of view, since it contributes to protect the toolkit itself. Most of Protego components run on Docker containers to achieve process isolation. The platform uses segmented, isolated networks internally. And externally, network flows can be isolated by using network slicing. Protego's services are not exposed directly to the network. They are locked down by the Istio control plane. This block diagram represents the resulting Protego integrated toolkit, or what we call the Protego platform. With this platform, applications are powered by Protego. To validate the platform, each hospital has selected an information system as a case study. Ospedale San Raffaele chose Food Coach. This case study is relevant because it gives a blueprint of how hospitals can extend their offer in the presence of increased security guarantees. It is the archetypal distributed application. There is an out-of-boundary data exchange, and it is opening up the usage of personal mobile devices. Marina Salud chose Pocket EHR. This information system was designed with a hybrid architecture using both on-premises and cloud infrastructures. This opens up many possibilities because traditionally medical applications were not deployed on cloud infrastructures for privacy issues. But with Protego protecting data in all its stages, that is not a problem anymore. So the benefits of Pocket EHR are the following. It describes a safe mechanism to exceed hospital boundaries in the design of technology-based healthcare protocols. It contributes to keep unique and unified electronic medical records, not creating new ones for each use or medical service. It introduces cloud infrastructure as suitable environments for Protego deployments. And finally, it represents an ever-growing strategy for organizations, the use of cloud services. With the first integrated prototype, there are a number of use cases that can be demonstrated. The first one and most obvious is the legitimate data access. That is, a user that has the proper permissions has access to the proper data. The second, and related to the first one, is user role unauthorized. This is an important use case because although it might seem trivial, there are many factors to be considered. The fact that a user has access to the application does not mean full access to all data. For example, imagine a hospital where doctors can only have access to information about their own patients. They will not have access to information about someone else's patients. Another example could be application or IT administrators. They can manage the application or the infrastructure, but will not have access to information about patients. This is a built-in feature in the toolkit. The third describes something that happens often. What if a mobile device, whether a phone or a tablet, belonging to medical staff or patients with an application installed that has access to sensitive data, is stolen or lost? With Protego, the continuous authentication capabilities of the toolkit will block access to protected data and raise an alert to the SIM so that security operators are aware of it. Let's now focus on a couple of attacks that can happen either externally or even internally. Imagine that for some reason an attacker has access to the device where Parquet files are stored. Maybe by breaking into some other system and performing some kind of lateral movement, finally reaches that device. Or imagine that someone that has legitimate access internally has a malicious intent. In any event, Protego protects data. Now, this attacker with access to Parquet files tries to tamper them. The encryption that is used, AES CGM, is an authenticated encryption which creates and verifies data signature upon encryption and decryption operations, thus performing an integrity check. But what if an attacker tries to replace a whole file that passes the integrity check, but is duplicated or outdated? A unique file ID is fed as an input into the data signature. The data gateway will detect any attempt of tampering the files and raise an alert to the SIM so that security operators are aware of it. Another attack that can be demonstrated is the attempt of eavesdropping encrypted data. Even if an attacker has access to files, can sniff network traffic, or tries to dump memory pages, due to encryption, data will be unintelligible. And finally, Once an initial model is created for risk assessment in the SSM, the detection of vulnerabilities by the CM can be used to recalculate risk levels. Besides the technology used and the research carried out, part of the success lays in the functional framework that defined functional and non-functional requirements that detailed representative real-life situations and introduced a set of related evaluation metrics. Starting with the stakeholder map, everything has been identified and defined in detail. Use cases have been identified and well documented. Even storyboards have been created. Besides all the technical work described so far, a lot of effort has also been put into the educational framework. Before starting to prepare any material, it was necessary to assess the level of cybersecurity awareness among hospital employees. So an online survey was prepared. This is a tool that makes it possible to benchmark different organizations or the same organization at different points in time. It contributes to study the underlying factors of cybersecurity behaviors and helps to get requirements for a tailored educational framework. The survey was made up of 24 multiple-choice questions. In both hospitals, Marina Salud and Ospedale San Raffaele, staff was invited to participate. In total, some 300 healthcare employees provided invaluable feedback that helped to gain insight for the design of the educational framework. With this feedback, the user risk awareness profile for each organization was created based on key items of the survey. This risk awareness profile shows the cybersecurity areas to improve. Besides making it possible to benchmark different organizations or the same organization at different points in time, this profile makes it also possible to benchmark different user types, those that have jobs in different functional areas. Basically, the impact of concrete actions can be measured. Using the stakeholder map previously mentioned and based on their educational requirements, different groups were identified: health staff, IT staff, patients, external providers, and regulators. To briefly mention one of the groups, probably the main one, let's focus on the health staff. To tackle the needs of this group, a rising awareness program has been created. It is based on Gartner's people-centric security concept. It addresses BYOD threats, outlining easy principles that can easily be incorporated into daily actions. It is feasible to be executed in different organizations from different countries with minimal changes. And it includes graphic materials such as posters, web banners, etc., with direct messages that include recommendations. Those materials can be easily consumed by health staff when located in their workplaces. The following are the achievements that can be highlighted so far. We defined functional and non-functional requirements, detailed representative real-life situations, and introduced a set of related evaluation metrics. We created integrated tools for decision support on how to respond to an attack. We developed Parquet modular encryption. The development of Parquet modular encryption, a central part of the architecture, has been highly successful been officially accepted as a standard by the Apache Parquet community and already integrated into commercial offerings. We developed a modular access control framework. We created the first endpoint detection and response system with continuous authentication capabilities. We created network slicing for wired and wireless networks. And we put all of this together into the first integrated prototype. We designed a racing awareness program after surveying more than 300 healthcare employees. We have engaged with the community, and proof of that is the workshop that is taking place today. We have produced 14 scientific papers. 5 have been accepted, 3 are in review, and the rest are in the pipeline. What has been described so far is basically what has been achieved halfway through, up to June 2020. The project will conclude by December 2021. So if you want to keep up to date with the project, you can visit the website protego-project.eu. There you can find, among other things, publications, deliverables, and a new blog post every month. This is a list of the accepted publications. They are available for reading on the website. Since what has been presented covers half of the project, we will briefly describe the foreseen future work. We will continue refining and defining interactions, use cases, real-life situations, etc. The development of new functionality that is necessary to accomplish the objectives will be tackled. An important part of that new functionality is related to artificial intelligence. This will be used to improve decision support, to improve detection capabilities, and so on. Integration work of toolkit components will make the platform more efficient and more productive. The educational framework will be completed. Training sessions will be executed, and we will elicit the impact of the training sessions. The educational framework will also include tutorials and guides to deploy and use the Protego toolkit, as well as recommendations and best practices. More testing iterations will take place to validate the toolkit. All this work will give us a chance to produce more scientific publications. We will participate in more dissemination activities. We don't know whether we will have to do them online, like this workshop, due to the current situation, or we will have the chance to do them in person. Finally, as an important part of the project, we will have to prepare an exploitation framework that includes project impact, exploitation actions, and sustainability plans. And now that exploitation has come to the fore, which includes market analysis, business models, and so on, let's briefly analyze the cost of a data breach. We will use information from a report published by IBM every year. This year's report, the report for 2020, analyzes 524 recent breaches across 17 geographies and 17 different industries. Nearly all breaches resulted from malicious or criminal attacks, not glitches or human error. The average total cost of a data breach is $3.86 million. In the specific case of healthcare, which is the most expensive industry, that cost rises up to $7.13 million. One of the reasons why the average cost for a data breach is so high is because the average time to identify and contain a breach is 280 days. We can clearly see why an investment in a project like Protego is absolutely necessary. And this concludes the presentation. Thank you very much for your attention.
Hello, I'm Eleni Veroni, and I'm a research associate at the University of Piraeus in Greece. Through this presentation, we would like to introduce you to Curex, a Horizon 2020 project that aims at securing the health data exchange among European healthcare organizations. As data protection is now globally considered a priority, through our work and research, we hope to contribute towards the creation of a solution tailored to the particular needs of the healthcare domain. Curex is a 3-year research and innovation action funded under the 2018 call for trusted digital solutions and cybersecurity in health and care. The project officially started on December 1st, 2018, and today it is well through the second half of its implementation. The project is expected to end in November 2021. The Curex consortium consists of 17 participants that together form a group with many areas of expertise capable of achieving the project goals. The most important quality of the consortium is its balance, including partners from the industry, different research institutes, and the academia. The Curex consortium is comprised of 2 large ICT industries, 6 dynamic SMEs, 6 academic partners, and 3 healthcare organizations acting as end users. Today, the development of Curex's main tools and components has been finalized, and we are entering the system integration and evaluation phase. At the same time, we are preparing for the end-user validation through the demonstration of the different use cases. Securing the digital healthcare infrastructures is crucial for the modern society. Due to the digital transformation which has taken all critical infrastructures by storm, the need to find a balance among security requirements, new regulations, and the human welfare is more pressing than ever. Every day, more and more paper-based health records are being replaced with electronic ones, raising new risks, vulnerabilities, and threats. According to recent studies, nowadays electronic records account for over 80% of health records in established markets. The emerging markets are in the process of following the former's example. At the same time, no one can deny that the digital transformation has enabled more secure and better healthcare services for all patients. Thanks to the digital transformation, the modern healthcare provides patient-centered services, considering the practitioner's and patient's mobility, the usage of personal medical devices, the usage of commercial personal healthcare devices such as activity trackers, and of course the data sharing between stakeholders and service providers. As a result, the interconnections between the above form a complex ecosystem with many interrelated entities, which create a very large attack surface. To secure such an evolving and complex environment from unknown vulnerabilities and new cyber threats, secure by design devices and services are required. Moreover, a risk-based approach should be followed to help the higher management to act proactively against potential threats. The healthcare industry today suffers from data breaches the most, as the associated costs surpass the respective costs for any other industry. More specifically, in a recent study conducted by IBM, for the 9th year in a row, healthcare ranked first out of 17 industries, exhibiting an average cost of $6.45 million per data breach, approximately 65% more than the global average of all industries. This can be attributed to the fact that healthcare also holds the first position as the industry with the highest average cost per record stolen, double than the cost indicated for the financial industry, which ranked second in the same study. Finally, the results showing that organizations in healthcare require, on average, 329 days to identify and contain a data breach are highly alarming. It has been identified that the newly introduced threats against the healthcare domain are mainly targeting standard procedures applied to electronic health records. A significant and exceptionally vulnerable procedure that is often targeted is the health data exchange between different healthcare organizations. Health data exchange between different organizations takes place with the intention of advancing the services provided to patients today. Health data exchange may happen within the same organization where, for example, different clinics share data to effectively treat a patient. Another common scenario foresees the cross-organization transaction of medical records, where the data need to be sent to a different institution for further assessment. Moreover, there are medical cases where the cross-border transfer of a patient's health records is necessary, but those scenarios are rarely considered. However, this is about to change. All stakeholders can agree that the future of the healthcare services will be highly dependent on massive exchange of data, which, in order to be realized, increased connectivity is required between platforms, devices, and organizations. The interconnectivity, however, creates several security issues that need to be addressed beforehand, such as zero-day vulnerabilities and advanced threats. Every attempt against healthcare infrastructure puts at risk both patients' privacy and health, and may cause severe operational disruptions and major economic losses to the healthcare organizations. On top of that, the responsible authorities, through the legislation and directives enforced in European Union member countries, have created additional obligations for organizations that operate on clinical and medical data. One such legislation is the well-known GDPR. Due to the above, and considering the events of the recent pandemic, Curex's aim is more relevant than ever. During the first few months of the COVID-19 crisis, the attacks against the healthcare sector reached unprecedented levels, a fact that is corroborated by several sources. The current healthcare infrastructure, under the extreme pressure of the pandemic, were unable to handle the digital crisis happening at the same time. This had as a result for officials to resort to urging the attackers to halt their malicious activities that could lead to even more deaths during this global health crisis. The lessons learned from the recent events have reinstated the notion that reinforcing the security level of healthcare infrastructures must become a global priority. In this direction, ENISA, through several initiatives launched in the framework of the Cyber Europe 2020, works towards preparing the healthcare sector to respond to the cyber crisis that is bound to happen. To address the needs of the domain, we must first identify the requirements set by each stakeholders. In general, we consider four major stakeholder categories. First are the patients, who wish to receive high-quality services in all European Union member countries and want to be in charge of their personal data. The second category concerns the medical professionals, who need to have at their disposal all the necessary data in order to respond effectively to medical situations, even if said data reside in remote locations that are being controlled by other departments or organizations. After that, we have the healthcare service administrators, who need all the necessary information regarding vulnerabilities and threats that emerge from each operation. Moreover, administrators require proper support and advice on selecting and applying methods and countermeasures that will effectively mitigate cybersecurity risks. The last category, which includes the healthcare organization officers, demands tools and procedures that will ensure an organization's compliance with the current legislation, improve the cyber hygiene culture among personnel, and minimize the impact of any possible violation of the hospital's infrastructure and data. To cover these requirements, Curex proposes a multidimensional, comprehensive solution which is comprised of 5 distinct areas. These areas have been efficiently merged under a robust and flexible architecture, as depicted in the following slide. Every area incorporates specific tools and components where each one has been designed and developed to support a distinct functionality. First is the Asset and Vulnerability Discovery area, which is realized through a set of tools comprised of the Asset Discovery tool and the Vulnerability Discovery Manager. Second is the Threat Intelligence area, which is comprised of 2 other tools, the Knowledge Extraction Analytics and the Threat Intelligence Engine. Third, we have the Risk Management area that involves the functionality of 3 highly interactive tools, the Cybersecurity Assessment tool, the Privacy Assessment tool, and the Optimal Safeguards tool. Next, we have the Trust Enhancing area, which contains the Curex private blockchain. Last but not least, there is the Application and Visualization area, which incorporates the 2 Curex applications, namely the Healthcare Professional application and the Patient application, as well as the Curex Visualization tool. In Curex, we consider 4 major security challenges in healthcare. First, health data exchange introduces new types of threats. Second, privacy violations are more likely to occur when exchanges data. Third, the lack of a collectively accepted and auditable exchange record leads to reduced trust between parties. Fourth, the lack of human-centric strategies and methodologies for raising cybersecurity and privacy awareness in a healthcare institution. Now let's see how these security challenges are being addressed by specific functionalities of Curex, realized through different tools, components, and methods. Curex's response to the first security challenge is elaborated in 3 phases. First, the ADT and VDM tools collaborate to map the discovered system resources with possible already existing vulnerabilities. Second, the TN-KIA tools bind the discovered vulnerabilities with potential known threats, while also looking for abnormal behaviors which may disclose new and unknown threats. Finally, the cybersecurity assessment tool produces the risk assessment results of the infrastructure under investigation and feeds them to the optimal safeguards tool. The OST then proposes optimal countermeasures to the decision makers towards enhancing the cyber strategy of the healthcare organization. With respect to the second security challenge, Curex responds with functionalities spread across three different components. The privacy assessment tool, which, based on every business process that concerns the processing and exchange of data, assesses the degree of compliance of the healthcare organization with the GDPR by providing an indicative privacy score. The health professional and patient applications that are responsible to handle the transactions between the Curex private blockchain and the hospitals that wish to exchange medical records, respecting the GDPR rules and enabling consent management. Finally, the Curex private blockchain that uses smart contracts to comply with the GDPR and record the risk assessment reports in the network. Additionally, Curex uses its private blockchain as a distributed database where the scores of cat and pat will be recorded, facilitating the traceability and auditability of the data, while also addressing the requirements set by the third security challenge. Finally, the most significant and weakest link of the security chain has always been the human factor. To this end, Curex will employ a large-scale survey on cyber hygiene that is expected to engage different healthcare employee groups, addressing them a series of targeted questions to extract knowledge and understand the group-specific gaps and needs with regards to raising cybersecurity and data privacy awareness. To test the effectiveness of the Curex solution, three different use cases have been designed. The first one is about data exchange for cross-border patient mobility. The second use case concerns the data exchange in remote healthcare services. This use case has been broken into two sub-use cases, one for risk assessment for an IoT healthcare platform and another for risk assessment for a point-of-care system. The third Curex use case is about the data exchange for healthcare research. In the following short video, we briefly present the three use cases and the role the Curex private blockchain has in each one.
Now, let's talk about which role the blockchain plays inside Curex. Curex has defined three main use cases, and in each of them, the blockchain plays an essential role to ensure the traceability of the data as well as GDPR compliance. In the first use case, we consider a situation in which a patient, here in blue, is hospitalized in a foreign hospital, here in black. In order to access the patient's medical data to cure them, the black hospital sends a request to the patient hospital. This request must be agreed on by both the patient and the blue hospital before the data is transferred. Because health records are critical data, these requests must be traceable and available for audit. Hence, all the requests and the status evolution are stored in the blockchain for auditability and facilitating the execution of GDPR rights. The process has been specially designed so that no personal data is stored in the blockchain. Furthermore, the smart contracts make all the security-related checks, verifying that at each step of the process, nothing is amiss and no one is usurpating anyone's identity thanks to public key cryptography. In use case 2, we consider the problematic in which hospitals have to store and make available their risk evaluations. As a matter of fact, in use case 1, the decision to transfer the data or not depends on the receiving hospital's call. For instance, a hospital can deny a data transfer if the PAT score is too low. Hence, these calls must be accessible by anyone in a secure manner. For this reason, we developed an API on which the organizations are able to query and to update at any time they want the risk scores of their entities. Finally, the third use case is an interaction with another European project, My Health, My Data. This project allows hospitals and medical universities to exchange data for research purposes. The goal of this use case is to open a channel between My Health, My Data and Curex blockchains, so that the My Health, My Data hospital will be able to rely on the risk evaluation from use case 2 of Curex to make their decisions whether or not they accept to send the data. For instance, assume that the Black Hospital wants to do research on a disease for which Blue Hospital has a lot of data. Through the My Health, My Data blockchain, Black Hospital sends a query. Upon receiving the query, Blue Hospital checks Black Hospital's calls stored in the Curex platform. Thanks to data oracles installed on the Curex blockchain, this query is mirrored on the My Health, My Data blockchain, and the process can then continue on My Health, My Data. This is done via an interaction of the smart contracts of both blockchains, thus allowing interoperability between the two European projects.
Hello everyone, my name is Carmela Troncoso, and today I will present DP3T, a decentralized privacy-preserving proximity tracing effort. DP3T is a collaborative effort. I will be presenting this, but I want to make sure that you know that the work I will present today is the result of the effort of many people that, led by EPFL and ETH Zurich, put a lot of work into creating a privacy-preserving proximity tracing protocol. Digital proximity tracing aims at being a complement to traditional contact tracing. In traditional contact tracing, when a patient gives positive for COVID-19, the doctor asks them who were their contacts in the last weeks, like close contacts, people that could have been infected. And then once those people are identified, they got called and told to take action like self-isolating or take a test. Traditional contact tracing was thought to maybe be ineffective or not effective enough in COVID-19 pandemic because as the number of cases is very big, it is not possible for contact tracers to actually handle all of them. Also, this amount of contact tracing is limited by the amount of information that humans can remember. What happens with the people that you are in the bus with, which can be infected with your COVID-19, but actually you don't know their names to identify. And also, because COVID-19 spreads very fast, it's very important to catch these chains of infections very timely. So the goal of digital proximity tracing is to notify users, right? To not to identify them, but to try to get a notification to them whenever they have been exposed and they are at risk of infection. So how the DP3T protocol works is as follows. Whenever the user installs an application running this protocol on a phone, the phone creates a secret every day, and from this secret it derives random identifiers. These random identifiers are used for a limited amount of time. The goal of this is that this identifier does not become the means to track people over time. These identifiers are all the time broadcasted via Bluetooth. But if you don't have the key, this secret that is held on the phone, you cannot really link these together, and therefore you cannot track people. As people walk around and with the app broadcasting these random numbers, if another phone with the app gets close by and listen to this number, it will record the number together with information about time and some information about the power which the number has been listened to. And you can think about this power as a proxy for the distance, the same as the volume of the voice would tell you how close or far away I am from you. In this case here, we can see that A and B are considered close enough to each other, and they both will record each other's phone. Well, C apparently is not close enough to A, so he will only record the number from B. When a user is positive, how the system works is that this user is given an access code by the doctor, and with this access code, they are able to upload the random numbers to the server. Actually, they do not upload the random number, they actually upload their keys for efficiency so that the other users can derive the numbers. And what is very important is that these numbers are actually not related to the user's identity. They are created on the phone without using this information. They are not related to the locations that the user visits. They are actually created on a schedule, so they don't really correspond to the user actions. And they are not related to the user's behavior, how many people they have seen, for how long, or how frequently, as they only refer to the user itself. Whenever once the numbers are up, all of the other users go periodically to the server and download any new numbers that have been published. And then internally, they check whether they have seen any of the numbers. Once they have the list of all of the numbers that they have seen, they check whether these numbers, given the time that they have been seen, actually amount to having exposed to those numbers for 15 minutes, and then they use this information about attenuations of the signal to estimate if that exposure was close enough to actually be considered at risk. If the exposure score is large enough, then the phone will show a notification for the user asking them to follow an action. In the case of Switzerland, the users are prompted to call an info line that will give them more information about what to do. This design actually follows security and privacy by design, in the sense that the only information that ever leaves the phone are these random numbers. There is no identity, no location, no other information about others. As such, there is no information in the system that is available for reviews. The information that is sent to the server, if you get hold of it, you cannot really use it for anything else that is not the protocol that it was thought for. Additionally, the system is conceived to sunset by design. What does this mean? When all of this idea of the apps started, people were worried about the fact that once they were in place, they would never disappear. In this system, because you need the action of the user in order to put the keys on the system for the full cycle to work. If users themselves decide that they don't want to participate anymore, they don't upload the keys, the users can actually shut down the system, even if the government would like to keep it in place. I encourage you to read our security and privacy analysis of digital proximity tracing systems if you want to know more about the trade-offs of security and privacy, also related to the fact that these protocols use Bluetooth Low Energy. And this protocol I have just talked about is just a very small piece in the puzzle of building these contact tracing applications, right? This took a little bit of time, but once we built it, we discovered that this was just the beginning. This protocol needs to be integrated on an app that actually lives on a mobile operating system. It needs to fulfill the law and ensure that society is accepting the system, and it also needs to fulfill the needs of the epidemiologists and the health system, and more importantly, it needs to be integrated in the health system in such a way that actually can work. It is for this that the Deep3T team is not just a couple of people that know about privacy, but rather a group of more than 30 researchers from 10 countries spanning a huge amount of disciplines, from privacy and cryptography, which is what you would expect, but we also had experts on wireless security to help us with the Bluetooth side. We had people expert in requirement engineering that help us talk with epidemiologists and get the requirements correctly, ethicists that could ensure that we actually build something that was respectful with users, and of course lawyers that help us make sure that we were in compliance with data protection law. The depth of the study actually caught the attention of big mobile developers, and both Google and Apple in April decided to incorporate this type of protocols on their operative systems at that point as part of the middleware, and they both said that they had taken a lot of our protocol and our studies as an inspiration. Our studies also had a huge impact in Switzerland. In fact, they are now the very basis of Swisscobit, the contact tracing app that we have here. We have not only designed the protocol at the underlying that now is in the Google and Apple exposure notification, but we also designed a lot of other security and privacy mechanisms that we have to build around this exposure notification protocol in order to make sure that the very nice privacy properties of this protocol are not lost as the system and the app are integrated in a bigger ecosystem with the health system, with clouds, etc., etc. And right now, after a month and a little bit of being deployed, we have very promising results, and the app is growing in Switzerland. Here in this graph, you can see the number of active users. That means those that actually not only have installed the app, but have it working. Currently, we have 1.6 million active users, around an 18% of the Swiss population. And in red, you have the number of COVID codes, the percentage of COVID codes that are entered in the system. Right now, we had more than 1,000 codes that have been entered, and on average, this is 12% of the positive PCRs in Switzerland. which we believe is a good result. It's more or less the same as the number of active users. That means that if you have the app and you're positive, you're very, very likely to participate into notifying other users. We have very nice and promising results with respect to effectiveness. So far, we have found 26 positive cases that would have not been tested without the app existing. And we also have the first indications of speed, that actually the app in some cases is faster than the manual contact tracing. The key lesson to be learned, and I cannot stress this enough, is that for the process to work properly, it needs to be very well integrated into the health authorities and into the physician's process. Switzerland is not the only country that have this, thanks to the integration of the protocol in the Google and Apple explicit notification API. Nowadays, many countries already have an application that uses this. That means that these applications can be interoperable, which means that if now I go to Italy for vacation and then I come back to Switzerland, if I have a positive, I am able to notify Italian users that they should take action, or if one of them is positive in Switzerland, I would also receive notification that someone that I have been close to is now COVID positive, and therefore I should take action myself. For this, it is important that people can retrieve the keys from other countries, and also that they can push their own keys to other countries so that everybody can be notified. The approach for this interoperability right now is being led by the European Commission, and hopefully in October we will actually be all interoperable, and notifications will cross borders. So in summary, the privacy preserving proximity tracing is the first privacy by design product that has been really developed and deployed at large scale. And by large scale, I mean right now European, but soon to world scale. And this has been done in collaboration with key players in the mobile industry, which for the first time have opted for a purely privacy by design solution. But as I said, this international collaboration is not ended. We're working on this interoperability and making this work again in a privacy preserving way. And we're also working on coming up with good effectiveness indicators that are homogeneous across Europe, so that every app in every country can get some indications of performance that we can compare, and then as a community decide whether these apps are working or not. Thank you very much. I'll be happy to answer your questions.
Good morning, good evening, good afternoon, and thank you very much for the invitation to present at this event. I'm going to stress throughout my talk about open COVID-19 data the following issues: the Research Data Alliance guidelines on sharing COVID data, a little bit about open science and the principles behind open science that foster sharing and reuse through openness. In particular, some of the challenges in sharing and reuse and data protection. And finally, this initiative I co-coordinate of opening Brazilian COVID-19 data. So the Research Data Alliance is an organization that involves over 140 countries with about 11,000 researchers, practitioners, innovators, whose goal is to share and reuse data for across technologies, disciplines, and countries to address the grand challenges of society. And I recommend, if you do not know about it, to become a member. This is its site, and in particular, it has just published in June a set of COVID-19 data sharing recommendations for the European Union which are available in this report and that cover clinical data, omics data, epidemiological data, and social sciences data with cross-cutting themes: community participation, indigenous data, legal and ethical considerations, as well as research software for data sharing on COVID-19. So part of my presentation is inspired by these recommendations. Excuse me. And the other part is inspired by open science and why open science is critical to combating COVID-19. And the reason it's critical is that because it allows collaboration without borders through sharing research outputs, in particular research data. But what are the benefits, challenges, and actually also problems on opening data? So I also recommend this report from the American National Academy of Sciences, which says if you want to practice open science, and let's think about my context, provide and share open data, you have to plan your research towards reuse, towards sharing of publications, of data, of methods. And in this context, open science can be thought of as data sharing and based on data sharing and reuse. So sharing and reuse, and I thank Lance Waller for this very good example. You can think of sharing and reuse as having parts, pieces, data items, which are open and that can be put together to create something bigger or something more comprehensive. In this case, a guitar. But these data items or pieces were created with the guitar in mind. What other ways could reuse be thought of? Reuse could be thought of as in a collage in which the original data items were created for a given research but were reused to create something completely different. In this case, a chair and a newspaper and other artifacts were put together to make up an object of art. So when you open data, among other challenges, is that it can be used and reused for other purposes. So how to protect data against any possible kind of reuse. So an example, these COVID clinical data can be used in data analysis to provide a paper that analyzes that data, but if combined with other kinds of data, for instance, it can result in school reopening schedules. And the first example is a guitar example. The second example is a collage example. And what are the challenges of opening, which means reuse? This report, whose writing I coordinated, it is centered around this figure in which open science is represented as global collaboration without time or spatial constraints, in which researchers all over the world publish their research outputs, which are reused by others, thereby improved and accelerating science. And one of the main issues about sharing and opening is trust. And this is a very interesting result of a report of last year's study in which Americans say they're more apt to trust research when data is openly available. So opening is not only to accelerate research or to create transparency, it creates trust as well. But what would be some of the data protection challenges? First of all, if you think about open science by design, you have to plan your research so that data becomes open, but it's also protected while open. Moreover, what is meant by data protection? What is to be protected? The data, or the individual when it's about individual data, or both. So some of the data protection challenges, for instance, individual, how to eliminate identification of that individual for future guitar, but also collage. And collage is much harder to anonymize or pseudonymize because different sources of data are going to be combined. Security, data quality. If you try to protect the individual too much, quality may decrease. Trust and ethical use. How to ensure ethical uses of data? By protecting the data, this is very hard. Moreover, for COVID-19 data, there are some organizations, including WHO, who says there should be an opening window and then the data should be closed for some cases. But data are a treasure. So should we close this treasure? What about future crises, future pandemics? These data are going to be used forever, maybe whatever ever means. So, and what is the cost of openness and preservation while maintaining the protection? And what kinds of data are we talking about when we're talking about COVID-19 data? Most people I talk to think about health data, health records, image data, socioeconomic data, omics data. Others will think mostly about tracking devices and the danger of governments finding out who you are, where you are, what you do. Big Brother. Others think about personal data provided via apps, but COVID-19 data to create collages has to be combined with standard of living, cultural, environmental data, and so on and so forth. Should it all be protected? At which levels? Is it the data? Is it the individual? In this sense, and to finish up, I'd like to show you an example of this project, a repository whose organization and maintenance I co-coordinate, which is funded by FAPESP, which is a very important funding agency in Brazil. And just to situate it, I'd like to stress that 50% of all research in Latin America is produced in Brazil, of which half in São Paulo state. So the state of São Paulo is responsible for 25% of all research produced in Latin America, and FAPESP funds research in all fields in the state of São Paulo since 1962, with 1% of all state revenues dedicated to research. To give you, in all fields, to give you an idea, all proposals are peer-reviewed, with an approximate 26,000 proposals processed in 2019 alone. Not all of which approved, obviously. Now, FAPESP has launched in March a series of initiatives towards and around COVID-19. This is the page, of which the one I'm involved in this repository, they're called FAPESP COVID-19 Data Sharing BR, which is an open COVID-19 medical data, clinical data. In which context does it work? FAPESP and the state of promoted via its São Paulo State Public Institutions the creation of a state open research data network repository that was inaugurated December 2019 and took 3 years to design and construct. And because this had been created having openness and open science in mind, we were able, or FAPES was able to launch the COVID-19 data repository in June. What is the COVID-19 data repository? It's housed within one of the institutions, the University of São Paulo. That's part of the Open Research Data Network repository of the state of São Paulo. And the way it works is that several health institutions provide selected and pseudonymized data on patients, exams, primary endpoints, and these data HIPAA compliant. And this initiative was launched by FAPES together with the University of São Paulo, with data initially provided by 3 private health institutions. So it's an example of private-public consortium for the public good. And now many other hospitals and clinics are joining with their data, and present statistics are the following. It started on July 1st with 177 data on 177,000 patients. Right now it has 330,000 patients, 9.5 million exams. But the way the data were selected is the following. An individual who from March onwards was tested for COVID-19, whether positive or negative, in any of the data providers, these providers go back in time to the beginning of November and provide all exams these individuals took in these institutions, which is why we have 330,000 patients, but 9.5 million exams. So, for instance, if back in November someone broke his or her leg and went to one of the health institutions to be operated on and had exams conducted, blood exam, urine exam, whatever, the results of these exams also appear on our data so that comorbidities can be also studied. And these data has been downloaded from over 20 countries and has produced already, remember, 1st of July, it has produced already papers, plus Lab Network is a startup that has used these data in an artificial intelligence tool to improve its products. So while the 3 others are papers that are examples of guitars, Lab Network is an example of a collage. And what kinds of challenges and how we met them? Well, first of all, protection of individuals and of the institutions, the data itself, themselves. The original data remains with the providers who select and pseudonymize and send to the repository. All the procedures follow Brazilian individual data protection law, which is similar to GDPR. And the original data is kept secure at the health institutions. Also, at where it's kept at the repository, there's 2 parallel data storage systems to ensure that's always online. But we had a problem, and we still will have, because more and more institutions are providing data with huge heterogeneity. So we try to provide the minimum of standardization, but we do not and we cannot interoperate because each institution has its own systems and own standards. So the only thing we are standardizing are the data schemas, data dictionaries, and trust is ensured through the reputation of the health institutions that are the data providers. I've finished here, but I'd like to encourage you to look at the sources I talked about for more on open data, COVID-19 data, and recommendations, starting with the RDA report. Then the other report I talked about on the right side that covers these two concepts of collaboration and research through collaboration in open science. And finally, going to our website and getting, unfortunately it's all in Portuguese, but all the clinical data on 300,000 Brazilian patients. Thank you so much.